The contractor certification class is one of those that we have been doing since 1994. We were one of the first companies to ever start training contractors. And think about it, the segmental retaining wall industry really started in 1987. And so that's a blink of an eye in the construction industry. And to go from 0 square footage in 1987 to billions of square feet worldwide, there was some growth, some learning curves, some black eyes, some skeletons in closet. And one of those things is definitely proper installation. I mean, you guys try to do a good job every time you're on a job site. But if you don't understand the entire situation, or if you don't understand some of the shortcomings, then mistakes can be made. And so today, what I want to cover is make sure you understand proper methods of construction and answer some of those questions. And I do, again, encourage you guys to ask those questions. We've got a number of you on this call, which is fantastic, but please don't sit on those hands. Type a question in there. I've got this right here. The panelists can also help me with this if it's something local in the market, and I want them to be there as well. Okay. So I do have one. I got a quick text message that Norbert, I'm going to go ahead and open up your mic. I just realized that you're staff, so if you can go ahead and say something, that'd be great. You're live. Okay.
Yeah, can you hear me?
We can now. Go ahead.
All right, there we go. Yes, I'm Norbert O'Hare, and I am the customer service specialist in Indianapolis. Indianapolis has recently become a two-person operation, and I am number 2, and I am the face that our fellows will see when they walk in. And so I say, welcome to this webinar, and I'm looking forward to learning.
Perfect. Norbert, great. And if you guys know me at all, I know the Reading Rock team does. If you guys know me at all, you know I like to have a good time, joke around a little bit. So I'm just going to caution Norbert to make sure when you introduce yourself, try not to say you're number 2. That could lead people in a different direction. But no, I appreciate, Norbert, that you're on the call and all the assistance that you helped there in Indianapolis. I know there's a handful out there. So, all right. So let's get into the presentation. So my whole goal, again, raise professionalism in our industry so you understand what it takes to build these walls. You know, the only qualifications for building a retaining wall shouldn't be the fact that you can lift a block. And so when you look at this, we want to make sure we've got you guys, that customer base, familiar with how these work and distinguish yourself from competition. It's not that all the walls fail when somebody that's not trained builds a wall, but it is one of those that we want to make sure we got that proper methods of construction. And like anything else, this satisfies the need for formal training. So if anybody has gone through the ICPI, which is the paving training, and I know Reading Rock is assisting with that. And if anybody's gone through NCMA, and you're going to hear me talk about the NCMA or reference the NCMA a couple times throughout this presentation, and that is the National Concrete Masonry Association. They're as close to a governing body as we have in our industry. So you've got the Allan block, and we're members of the NCMA. Reading Rock are members of NCMA, and we sit in groups and try to figure out what's good for our industry. So it's kind of a committee-based thought process that way. So you'll hear me how Allan Block has led the way in a lot of different ways, and how NCMA kind of supports what the industry is doing. But they've got a certification class to it, and that there's only 2 nationally recognized certification classes, Allan Block and NCMA. This class counts for 7 hours of continuing education credits for both ICPI and NCMA. So some of you guys might be very interested in that. The last page on that test, and feel free to download those tests. You can work on that throughout the presentation. We're going to have breaks, and you can kind of ask some questions to me and the staff as we go through this, but feel free to start filling that out. In fact, I'm going to probably say, guys, there's going to be a test question on this, but that last page of that part 2 is an ICPI evaluation. So if you want continuing education credits, make sure you fill that last page out and send it back to me. And that way we can process not only your certification, but then also your continuing education credits. And I got a couple things popping up here a little bit. I got Okay, so we've got a number of you guys that are viewing multiple or one screen, and there's multiple you in attendance, and that is perfect. That is not a problem. What I want you to do is everybody pay attention to the screen, participate in the presentation the best you can, but you each need to fill out a test, because I'm going to use between the login information of the class and then the tests that are returned back to me, that is going to complete my sign-in sheet. So I'm going to use both as that control. But if you do have multiple attendees, what you could help me out with, go ahead at this point in your question feature, go ahead and type in the names that are also attending with you. So let's just say I'm going to pick a name. Joel Miller, you sent me a little note before, but Joel, if you've got multiple people with you, go ahead and say Joel Miller and then type in the other names that go with you. So put who the registration is and then who else is attending right now at this point, and that way I've got a little bit of way to check as the tests come in too. So please go ahead and type those in. I'm going to let those pop in. Then I know they're not questions, but they're more for my information. So if you've got multiple attendees, feel free to type in that question feature right now. Who's also looking over your shoulder, and that'd be great. And that way it also gives you some practice using the go to webinar options as well. Okay, so some of the things we're going to talk about today, we're going to talk about just retaining walls, right? We're going to talk about how you can estimate what kind of labor is required, the equipment required to build these walls. Obviously, overhead and profit is something that I'm not going to be able to cover because I don't know what you need to pay yourself to keep your lights on. What kind of equipment do you need to reinvest in and stuff? And so I do challenge you guys to think of this as more of just a square foot price for install. Think about it as a square foot price to run a company. And there's multiple of you guys that are doing this. Great, thanks, Jordan. Appreciate that information. Then we're going to talk about market price a little bit. That's where I'm going to get the Writing Rock team involved. But you've got some great local resources there. Use that team to your advantage. These guys have been doing it a long time, and I don't mean to tell them that they're old, but you got some nice seasoned veterans that understand the hardscape market, not just segmental retaining walls, but the hardscape market. Leverage that. That is the real reason why I want to position yourself in this market to be successful. We are going to focus on retaining walls. That's the goal. You know, whether it is this 60-foot grade change, multiple terraces, or just this 6-foot high wall, all right? And so we know the bulk of the work out there is 6 feet and under, 2 meters and under. I know we're all in the US, so 6 feet and under here. And so how many of you guys, and we're going to kind of practice this a little bit. So I've got all the hands lowered right now. I want to just get your guys' feedback. How many of you guys would agree with this statement? And raise your hands if you agree, leave them, keep them lower if you don't. Building a retaining wall, actually installing the block from the pallet to the wall is one of the easier parts of building a retaining wall as far as effort and time. So how many of you guys would agree with that statement, that moving the block, bringing the block and putting it in the wall is one of the easier parts of building a retaining wall? And I see a lot of hands popping up. This is great, okay? Great, a lot of you guys, almost probably 2/3 when I look at this. All right, so I'm gonna lower the hands just so I keep this fresh and stuff so I can do this. All right, so most of you that have built this retaining wall, so now I know I've got a pretty seasoned group here, which is great. Most of you guys realize you spend most of your time moving the dirt, recompacting, backfilling, maybe even moving the grid out and cutting it. There are so many things that take your time. Actually, taking the block from the pallet goes pretty quick. And so if you're good at building a retaining wall, it is more about logistics than about actually the install side of it. And so being smart how you stage your equipment, stage the materials. And so that's the difference. So if you can build a 6-foot high wall, you can build a 60-foot grade change. It's just being smart in how you handle those logistics. All right, I did have a question pop up here. Faraz, you said, where is the booklet is the test? Where in the booklet is the test? So if you have a binder, all right, the binder does not have the test. It's easier to do the test electronically because it's just a fillable PDF. So if you do not have that test, you can go ahead. It's one of the handouts on the GoToWebinar. You'll see that there's multiple handouts in there. You've got 2 parts of that test. Go ahead and click on that, download it. If you got another screen, that's fine. Otherwise, just you could print it out and stuff at one of the breaks, but you can grab that test that way. And guys, I appreciate you guys popping in multiple attendees. This is good. It's going to help make my job a lot easier when it's all said and done. We do have in that binder, so a lot of you guys did get that contractor certification binder. We do have the fence information, and this is a wonderful product. Whether you're talking about a sound wall that's 35 feet in height, or just that separation between mixed-use properties. This is a homeowners association next to a busy roadway, and this is only 8 feet in height. You can see the ashlar pattern, dress it up a little bit. So if you ever have a customer that's looking for that privacy containment, that sound barrier, don't shy away from the Allan block fence system. The Reading Rock team has this. They're fully support. They understand how this works, but you can build it. It's just stacking these block up. And what's nice, remember that question I just talked about, how many of you guys would say that building the retaining wall is more about dirt than block? We don't have to worry about a lot of the dirt on this. So you stack the block. Now we do fill the cores with some concrete and some steel, but don't shy away, guys. You can build this fence and have a nice little offering for future customers out there. And you have some information in that binder. Now, what else is in that binder? You got a little bit of information about the courtyard. This is that above grade seat wall, kind of non-structural. They kept us engineers out of this. I got to admit, if we could have called it the Allan block Lego and not gotten sued, we probably would have tried, because it looks like a giant concrete Lego. But it is perfect for those above grade seat walls, defining that outdoor living space. That's where we've seen a huge boom in 2020. Everybody was confined to their homes, so you guys were busy. I'm sure you were, when you look at the amount of opportunities you had, whether it's pavers, these outdoor living areas, and we have products to help you support that. So whether it's the split or non-split, Reading Rock's got that New World courtyard as well, which is a non-split option, and that way it just gives you another look. We know a lot of people are looking for these clean, modern textures out there. So let's get into the Allan block advantage. You're going to see obviously Allan block on just about every screen. You're going to see that I've got Allan block on my pullover here, but this is not going to be Allan block specific. Yes, I feel like we've got a great stable of products, and the block that Reading Rock makes is second to none. It's high quality, it's durable, but really where the advantage comes into play is really who we introduced this morning. And I know you guys felt like, okay, let's get onto it. But we have a nice team of Reading Rock staff here, and the way they service the market is where you guys can really take advantage of that. And like I said, leverage that. There's some seasoned veterans there to help answer your questions. And there's other tools and programs that we run with conjunction with our production partner of Reading Rock, and that's helped to grow the market. When it's calling on engineers, it's calling on these developers to try to create that demand. And one of them is this best practices push. This is truly a zero wall failures initiative. And what do I mean by that? We are calling on engineers, because there is no class in a university or college that teaches these guys how to design a retaining wall. So it takes the Reading Rock team, it takes guys at Allan block to call engineers and teach them proper methods of design. And that's what best practices is all about, making sure they understand what needs to be done in the design side, and then you guys can do what you're most comfortable doing, which is actually building the wall. It takes you out of that equation of having to go through the design all the time. And so that's a huge push that started in 2015 by Allan block. It was adopted by the NCMA in 2017. So this is truly an industry initiative. Now, a couple pictures here. This is a project out in New Jersey. HNA, Hardscape North America, right in your guys' backyard. You guys are probably very familiar with it. Allan block has always been right there in contention with the awards. 2018, we did get shut out, so we're not real happy with that. But anytime you guys work on projects, love to get those pictures. That's the whole idea. This is a project down in North Carolina, but you can kind of just see the different use of segment retaining walls. And that's what I like about this industry. That's why I've been with it for almost 20 years. It's not about the block. It's about what that block gives you. Nobody wakes up in the middle of the night and says, man, I really want a retaining wall. All right, maybe some of the sales guys do, and I know maybe I do, but that's not the customer. What do they do with retaining walls? They create that flat, buildable land. So we know retaining walls are needs, and it's just fun to see how they do these hardscape projects to create that outdoor living space. This is a project in Indiana. Love this project, where now all of a sudden they got more usable land. Obviously a very complicated design we talk about some global stability. here. I know Jill Fouts was involved with this project, but just a great use of product to give them that flat buildable land that we've talked about. And everybody kind of thinks that this is Allan Block Corporate on Mount Allan Block, but this is not. This is just an office development on some unusable land made usable by segment retaining walls. So why are you here? The whole goal of why you're here is to increase opportunities for your growth, to increase the opportunities for your success. You're going to learn how segment and retaining walls can be a very viable option for you. And if you're very good at this, it opens up more possibilities. Now, we want you to join our team. We want you to differentiate yourself from other competition. Being a certified Allan Block wall builder means something. These are the guys that we like to partner with. These are the guys that I know the Reading Rock team are getting leads to and from. I mean, it is part of that inner quality circle that we always strive to have. We want to push for that design. We want to push for quality install. Obviously, we want to make sure you got a quality product. That way we've got success on every step. And we want you to be part of that. That's the whole point of these certification class. Obviously, building that reputation is huge. And we do partner with Home Advisor, and I'll get more into this. Home Advisor is just an opportunity for you, and it's just that Angie's List counterpart that it gives you potential leads on future work. And through our certification program, because Home Advisor approached us, they said, okay, we'll give your certified wall builders discounts, rebates, and stuff like that if they want to be part of Home Advisor. And I know there's a lot of contractors that absolutely hate Home Advisor because of maybe past experiences, but I know a lot of contractors that love it because they're booked up for a year and a half because of how much work is coming in through that electronic channel. And so it really depends on how you set up that account, and we can help you with that. We've got some online training and stuff that Home Advisor has done to kind of maximize that account for you if you're interested. But that is now an opportunity because you're going to become a certified wall builder. And then rewards. You know, I took a picture of our back training room, a little bit of Allan Block swag. Everybody likes the tool bags and the coolers and stuff like that. And it's just free, and it was just a way to thank you for choosing to use Allan Block on your next project. So certification, there are actually 3 different steps: certified, experience, and master. Certified is what you're going to be going through most of it today, okay? Because this is virtual, it looks a little different. Presentation is going to be the same. You're going to be listening to me. You're going to see my wonderful headshot there as we go through this presentation, but we're going to go through the basics. We're going to talk about why these walls failed. I'm going to show you wall failures because I think that's where we learn, right? Everybody has past mistakes, and our goal is to have far more successes than failures out there. So we're going to talk about proper methods of construction. The hands-on is going to look a little different. This is where you're going to have to leverage that Reading Rock team, and that hands-on could be at your next retaining wall project. They'll come out, they'll work with you, maybe show you a couple tips and tricks as we go through that. So, or maybe you can come to one of their RDCs and have a little mock hands-on there. Obviously, COVID-19 protocols in place, and so that's where this class differentiates from the in-person. Normally, we just go in the afternoon and do a hands-on demonstration. I do have a couple videos that I'm going to go through at the end here to kind of give you a little bit of a broad brush stroke of what this looks like. But then I want you to complete that test, and you can be working on this throughout the morning. So when you're done with this class, you've got almost all of the questions done, especially if you got a second computer or monitor you can do this on. But feel free to work on that test, and then I'm going to have you email that test back to me, okay? And I'll say my email address many times throughout the presentations, but it's just my first initial and last name, so cjulius@allanblock.com, and I'll put it up there again. But I want you to email me that test, and then I'll kind of get all the tests together, and I'll get it back to the Reading Rock team and all that good stuff. But I'm going to be the kind of the center hub for collecting that information, and so you'll have that for me. And if you even respond back to the emails that you got for this class, that goes to info@Allan Block, and I'll just make sure whoever's managing that info account sends me that stuff too. So you can get me that test in a lot of different ways, right? And I want you to complete that test, and then the last step is to just build that wall. You know, we want you to use the stuff that you learned in today's session. Okay, experience is just hence the name, just more retaining wall work. So we got 5 more retaining wall projects, range of conditions, right? We want something that's going to stretch you a little bit so you can learn, like I said, hence the name. And then the master wall builder, this is where you're doing about 25,000 square feet of it. And so this might take you a couple years to get to it, but that's okay. We don't need, there's no race to get to a master wall builder. Now, if you're fortunate enough to do a lot of retaining wall work and you can do it in 1 or 2 years, perfect, great. If it takes you 10 years, no problem. Your certification is good for your lifetime. You know, I mean, that is, you're taking that knowledge with you. And so we just have you work with Reading Rock and make sure we understand which projects you're working on. That's the missing element, right? It's hard to know, and I'm not trying to make any excuse here. It's hard to know where every Allen block pallet lands. And so if you are working on an Allen block job, just contact your local Reading Rock guys and just say, hey, I'm starting my next Allen block project. It's over here and it's about 500 square feet, okay? Then they can grab that information, log it, and we can just keep track of your experience. And as soon as you qualify for your experience level or you qualify for the master, that happens within our system automatically. And so that's important to us, and we want to be partners there as we go through this. Any questions on that? I see quite a few of you guys have logged in with multiple attendees, which is great. But now I'm going to make sure you guys, if you do have any questions, fire them off at me and make sure I don't miss something. But if I say something that's not quite right, and guys, Reading Rock, I've got 9 staff members on here now. If I say something, you're like, I don't think he said that right. You've got the ability to unmute yourself and kind of correct me too. So hold me accountable as we go through this stuff. All right, so here we go. How do you promote this? We want you to update your resume. We want this to be part of your submittal, and we've got the ability to help create a little portfolio for you. So we've got your information in our database, and when you go through the class and when you get certified, and even what projects you work on. And so we can help create a nice little handout, little portfolio, and you can do it electronically or a hard copy, and this can be part of your submittal. So as you're selling yourself and your company to your potential customers, they know right away that you're an Allen block certified. Okay, there's future class opportunities, so you're going to be able to do online training. Every week we do online contractor focused training, and so this might be on a particular tool, might be on a hot topic like a no fines concrete backfill or something like that, which we'll talk a little bit about today. So those are ongoing, and we want you to participate with that. And as I mentioned, Home Advisor Partnership is just a way to maybe leverage that a little bit and work through that. Okay, so let's talk about the product itself. So now I'm done kind of with the programs. I want to get into the product, and then we'll get into a plan, design, build strategy to ensure project success. So the product is unique, all right? It's not the traditional concrete that I always thought of especially when I was growing up and even starting my engineering career. When I was asked the question, what is the difference between a wet cast concrete product and a dry cast concrete product, I didn't really know. So I still ask that question today to engineers and to contractors and stuff like that. And most people don't quite understand the nuances between wet cast concrete and dry cast concrete. The secret's in the name, obviously, but wet cast concrete is what I always traditionally thought about as concrete. It's the ready mix trucks rolling down the street, right? So in that drum that's spinning, you got your Portland cements, your sands, your aggregates, but they're adding water to it so it flows, it's liquid, all right? So it's got some workability to it. So it goes down the chute and they can pour it into a mold. Now that mold might be a sidewalk, mold might be a big block. We'll talk a little bit about that too. The big blocks might be a wall that's vertically, but it's got to hold that shape because that mold is holding it in place, right? It's not self-supporting, so it's got a slump to it. It works. Dry cast concrete is the same ingredients really, and I know I'm simplifying this, but it's the Portland cement, sands, and aggregates, but now we add just enough water to hydrate the cement. So the comparison I've always used is think about that sandcastle that you built as a kid or with your kids. What do you do with that sand? You add just enough water to get that sand to stick together. And so then when you do is you pound it in the bucket, get it nice and tight. So when you flip the bucket over, it holds its shape, right? that's in essence what, and again, I'm simplifying it from the Reading Rock team, and right now they're going, Chad, we do so much more than this. That's what Reading Rock does over and over and over again with Allen block. They got a mold that looks like two Allen blocks face to face, right? And they take this mix and they vibrate it and compress it into this mold, but then that mold gets stripped right away. And then it goes and dries overnight, and the next day they can split it apart. So that's why it looks like two Allen blocks. So that's the beautiful thing about dry cast technology, is that it's one mold, but you use it over and over and over again. It's almost like you're stamping out concrete block. And so they can make thousands of Allen block in a day. And that's why segment or retaining walls using like an Allen block product has an economic advantage over a wet cast system. So one of the many reasons why segmented retaining walls have gone from 0 square feet to billions of square feet worldwide in 33 years, because economics are there. The way that building material is used. And if you ever get a chance, if you're ever in Cincinnati, and some of you guys, that's your backyard, and you get a chance to do a tour of how these blocks are made, I think it's fascinating, and it gives you an appreciation of how these blocks, the height dimensions, the durability and stuff like that. And so the blocks that were manufactured in the late 80s look a lot different than what we're seeing now. Because obviously in the late 80s, we were just kind of making things up a little bit. You know, we were taking what was good for foundation blocks, those CMUs, those masonry units, and the compressive strength wasn't there. So ASTM C1372. And if you're following along in your book, and I encourage you guys to do that, you're going to see some page references here. So in that commercial install manual, and that is looking just like this. So if you are in your binder under retaining walls or installation, you're going to get this commercial install manual. Almost all of the questions and answers are going to be in this manual. It is, again, one of the handouts attached to this webinar. So if you do not have a binder, maybe it just didn't show up, your paths couldn't cross, you have an electronic version. Download that, have that as a resource. To me, it's one of the best things that we have for learning retaining wall options. But in ASTM C1372, it is our roadmap for compressive strength and absorption, how durable that block is because of the northern climates that you guys find yourself in. That's 1262. That is ensuring that we've got freeze thaw durability. So when we're talking about DOT type applications or commercial applications, they are going to have requirements for freeze thaw. And so Reading Rock has gone through those testing and have complete reports and the durability and the quality that they're looking for. The other thing that is in ASTM C1372 are dimensional tolerances, okay? You guys have built a lot of retaining walls. I saw a lot of those hands pop up when I asked that question. What do you guys have to do, and this is rhetorical, I don't expect you guys to answer, but what do you guys have to do when the blocks don't line up on the height? Well, now you got to be shimming materials, or you might have to grind a few things. We don't want you to do that. And so in ASTM C1372, they say plus or minus 1/8 of an inch for dimensional tolerances. That's a lot. So Reading Rock has always held themselves to a higher standard. They always try to go to a plus or minus a 16. The goal is try to give you a block that's as perfect as possible. But if you ever get a chance to take that tour, you're going to understand there's a lot of moving parts. And so please, work with the team, let them know what you're seeing out there, but that's all being outlined there in the ASTM standards. Okay, if you have any questions on that, let me know. Especially if the Reading Rock team, if you got any comments, go ahead and grab my attention or just unmute yourself and go from there. But I do want to scream through the collections, just so you guys recognize names, recognize aesthetically choices. It's in the manuals, and I think it's important because you are going to get different customers that are going to want different aesthetic finishes, and they might even throw a name at you, and now you might be able to associate that with some of the training that we're just doing. But we've got different collections, and the collections just give you different aesthetic and price point options. So the AB collection is our workhorse. If you're using Allen block, chances are it is probably going to be in the AB collection. And then we've got the Europa collection, more of a tumbled system. We've got the Fieldstone, which is kind of our first attempt at a non-split face back in 2009. And then we've got even the Aztec, which is one of the fastest growing products we've introduced as far as the aesthetics go. But let's dive into this a little bit. All right, the AB collection is our workhorse. You know, in this collection, we got multiple shapes, multiple sizes, but then also multiple setbacks. Now, what do I mean by a setback? A setback is, what does it go from that vertical plane? How much does it tip back into that hillside? So if I've got a vertical wall, I'm straight up and down. If I set that wall back, I've got a pretty good, we'll call wall batter. So setback and wall batter, those are two terms that you might hear in our industry, and those are basically interchangeable. What is that setback into the hillside? And our full size units are the one that give you the different options. And I'm going to start with the original for us. When Robert Allan Gravier, he's our founder, he used his middle name as the namesake of the block. When he started the company, his block was the AB stones. And so you'll see if I do that section here, how much of a setback we're talking about here. That's 12 degrees. So that's a pretty big setback when it's all said and done. There's some engineering advantages to this, but there's also some disadvantages about that property lines and how much real estate you're taking up. But the block's nominal dimensions, 8 by 18, so 8 inches tall, 18 inches in depth, and about 12 inches deep. And so that gives you a way to kind of ballpark your estimates there. They're just under a square foot when you're looking at this. Then when you're looking here, I always have these pictures in for a reason, because to me, they're always teaching moments. You're going to find, especially architects, landscape architects, engineers are the worst. They like to draw straight lines. It's easy to draw on paper. So, you know, you're going to find some of these funny angles ending up on plan sets, or maybe you got a homeowner that's trying to match a timber wall, right? You're going to get these funny angles. Try to get them to turn curves as much as possible, because anytime you have angles like this, that's a mitered cut, right? Now that's a vertical seam in your wall, and that could be a potential weak point. Okay. Now the classic is the exact same shape. Okay, 18 by 12 inches, but now it's 6 degree setback, and this is the workhorse of the Allan Block product line. We sell more AB classics than anything else because you get the advantages of a setback, but you don't have all the disadvantages of losing all that real estate. And then if you do need something near vertical, some of you guys might work on some Department of Transportation work. We do have, really stretch ourselves for a name on this, called the AB vertical. There's a 3 degree standard for us. We do even have a 1 degree option if push comes to shove, but you can see that is creating that vertical wall. But that's something you're going to work with the Reading Rock team and making sure that gets ordered and ultimately shipped, because that's usually not something that they're going to sit on piles of inventory of. But I want to talk about this one. To me, the Jumbo Junior doesn't get enough love out there. I know a lot of you guys on this call do retaining walls, but it is still probably not the primary source of income for your company. A lot of you guys are doing pavers, maintenance, you name it. There's a lot of things that you guys do. Retaining walls are needs for you. All of a sudden you're working on that patio for that homeowner, and you need this retaining wall to hold up this patio to level it up. Well, if you have a lot of little landscape walls and you got a lot of little curves and tight radiuses and stuff like this, this Jumbo Junior is a great product. You know, it's a little lightweight, about 35 pounds instead of the 75 or 80 pounds, but now you can see it's half length. So it's only 9 inches wide by 8 inches tall. So it's still the full height, but it's only 9 inches wide. You can see the nice tight radiuses you're doing. We do have the light stone. That's the half high unit. And so for us, the AB light, anytime you see the word light, it's like half the height. Then this is all 6 degrees. So the only setback differences you have are on the full size block at AB stones and AB vertical. Everything else for Allan Block is 6 degrees. But this one we see very popular when you have people trying to match a limestone or a natural stone. The coursings are a little tighter, so you see them trying to blend that in there. And then the Junior Light, little ankle biter of a wall, literally 4 by 9 as far as the square footage there. So a few pictures of just the AB collection. I really like the look of the Allan Block. Obviously, I'm a little biased, but to me, nothing looks better than a properly installed Allan Block. They got that chamfer, nice clean line, very distinguishable. Unfortunately, you probably know where I'm going with this. Nothing looks worse than an improperly installed Allan Block, because now you see that line snake a little bit and it's pretty obvious, but that's where we concentrate on that base. but you can see how we look at this, just different use of the products, whether it's terraced walls. Here is a near vertical wall on property that is less desirable. You know, you've got that swampland below, you've got surcharges and railings above. It's making this land usable, but it's all about solutions. You know, working with the team that we have. So here, production partners got involved, worked with the local contractor that recognized an opportunity to maybe do a parapet. And they just, the GC and engineer were trying to figure out how to put some type of a barrier between your two different parking lots. And so a nice little change order when you're able to, you know, almost double your square footage by taking one, flipping the block up end for end, and now all of a sudden you can build this parapet all along the top of the wall, something that wasn't there. So you guys, I'm going to say this again, you guys are going to know more about the capacities or capabilities of an Allan block system than anybody else. And so if you feel like you can provide a solution, let us know how we can help you sell it. You know, that's the beautiful thing about this. You're not on your own anymore. You've got a team behind you to help you sell, help you leverage some of the options out there. Okay, so here we're going to look at just different colors, different textures, right? So you're matching the pavers. You know, that's where the landscape product comes in. How many of you guys do water features? You know, you're going to actually get sick of me talking about water applications or water management, because we know 2/3 of the wall problems out there is because of improper water management. And so if you ever need a customer or have a customer that wants that tranquility, that wants that water flowing, you've got to go to the nth degree, the severe degree, to make sure that water never gets trapped behind the wall. And here we're just using the Jumbo Junior as that grade separation and create that. Here, Ashlar patterns. If I do say Allan block has an advantage, like the block system itself, I would say how easily we can create the patterns is one of them, right? Listen, it's a front lip, bottom notch, modular. You got the full size, half length, half high. So you can literally stack these blocks up in any pattern you want, because they kind of pattern themselves out. They work themselves out. Now, we give you patterns to follow for really 3 reasons, okay? I want you to think about what you think these might be. One is definitely going to be for structural stability, all right? We got to make sure we have horizontal lines running through these walls, because when we need to add that geogrid reinforcement, we need horizontal lines. That's why we have 2 course or 3 course patterns, right? And I just mean by how tall they are, 16 inches, 24 inches. So you can get the different spacing between that grid. Okay, so structural stability is one, and we also minimize that vertical seam. We want to make sure that vertical seam doesn't go all the way through that pattern, which can happen. I was building my own personal retaining walls at my house, and I had 2 retaining walls under a tuck under garage, and then one side I was building a set of steps. And with these steps, I'm feathering them out, I'm peeling the courses back, and I'm doing kind of a little S shape in and out of these steps. Well, I was doing an Ashlar pattern. I love our Ashlar pattern. And to get into these steps, I had to deviate from our standard patterns. Well, before I know it, I had a vertical seam that was almost 3 courses tall because of how things were laying out. So I got to fire up the saw and make a couple changes, so that way I minimize these vertical seams. But following a pattern does that for you. So structural stability. One is ease of installation, right? I don't have to guess what block I'm going to put in next. I actually have been on job sites where contractors are arguing on what block should come next. You're not being all that productive if you're arguing on what block is coming in next. The last one is for really our logistics, is how much block do you need to deliver, right? And so if you're following a pattern, you can estimate how much block of each type you need that's going to be delivered to a job site. And that's, so these 2 course light, 3 course light. The only difference between your light pattern and your standard pattern is really we're removing that AB classic from the equation. So your light pattern is all the 3 smaller shapes, which is going to be more for your homeowner, is probably going to look at something this. You guys, speed, efficiency, and economics, you're probably always going to use your standard patterns, and this two course pattern is our most common one out there. Okay, so a few pictures of the ashlar pattern just kind of being used in just different applications. What I like about the ashlar, it just kind of dresses that wall up a little bit. It gets away from that commercial 8x18 look, and it just kind of a way to distinguish yourself from maybe other competition. So you just go ahead and look at how that might be used, and to give your customer that dream backyard. You know, something like this is a great application of segmental retaining walls. You know, they dug into the hillside, took this dirt and filled it and put it down here. So now they've got this patio overlooking this beautiful backyard or lake that's in Montana. And so using that ashlar dresses it up a little bit. But of course, what does the ashlar pattern do to your costs? It's going to go up, right? You've got multiple patterns or multiple pallets. You got a puzzle that you're kind of putting together, so you can't be as efficient. So obviously you got to be smart on how you're going to price this and propose this to your customer as well. So you can kind of just see how this works. And here's a great use of product where they just did a dash of ashlar. And I say this customer was price sensitive, and you're probably all thinking, well, all customers are price sensitive. But here they were able to use the classic for most of the wall, and they just brought in a dash of ashlar here to kind of dress that up a little bit. Okay. Now I brought in our newest collection at this point because really it's the same shapes we just talked about, classics, junior light stones, junior lights, but now instead of a split face, we've got that smooth hewn face. We always kind of say, well, we got our inspiration from the Cusco wall in Peru. You can see it's not perfectly smooth, it has a little undulation. That's really what we did with the Aztec. So we've got that classic, we got the light stone, we got the junior lights and all this other stuff, but now it's a smooth face. Kind of that clean modular look that a lot of people are desiring right now. You know, they're trying to get away from that split face. So I got a couple pictures here. Love this one. This one's down in the Florida DOT market, where they just did some abutment structures for that roadway area. This picture to me really shows you the texture of that facing. So you can see that it's not perfectly smooth. If you look real close, you can see a little bit of the lines on that wall. I love this as far as lighting. Guys, you're going to hear me give you my thoughts and recommendations throughout this presentation. You know, being involved with this, doing retaining walls every day, working with contractors like you guys, we want you guys to succeed. And so anything you can do to round out the services you provide. And if you are not doing landscape lighting, or you're not comfortable with landscape lighting, do yourself a favor, take a class. You know, I know trade shows are going to look different here in 2020 and 2021, but grab some information and learn how to do landscape lighting. It is a simple way to add money to your bottom line. I always compare it to what McDonald's did when they trained their guys to ask one question, and that question was, do you want fries with that? As soon as their counter people started asking, do you want fries, what do you think happened to their profits? Well, for you guys, anytime you're doing a paver job, you should always ask, do you want a seating wall or pillars to frame in an entryway? If you're doing anything for pavers or hardscapes, you should always ask, can we put some lighting in there for you? It is gonna enhance your offerings, and it might make the difference for you getting the job. If you can show them how these landscape lighting is going to just make it pop, it's that cherry on top, and now all of a sudden you've got a way to be more profitable too. So please do yourself a favor, know a little bit more about these landscape lights and use them. Yeah, get them in your quotes. So you can see how that just changes the look. Here's the Aztec being used. And again, you don't have to do a pattern. You can do that full size block. We get guys that are being very creative doing split face and non-split face kind of texturing in there. It's kind of nice to see. And then, like I said, it's all complementary. We got the cold caps and corners. This is the first Aztec job we did up in Whistler, up in British Columbia, Canada. Kind of an earth tone. All the planters and stuff, the landscape architect was adamant that there was going to be no split face product on this development. All right, now the Europa collection gets back to the traditional look, a little bit more of that split face, but you can see that it's more tumbled or crunched, so it's antique. So it gives that old world charm. And give it some more European names, so Dover, Palermo, Barcelona, Bordeaux, but it's the same block shapes, right? 8 by 18, maybe weighs a little bit more because it's got to survive that tumbling process. So instead of maybe 75, 80 pounds, it's going to be about 80 pounds or more. And so here's a great way to use these products to give you that different texture change. Now, some of you guys that have been in this industry for a while are probably looking at your trends, and I know the Reading Rock team is doing the exact same thing, looking at their paver trends. And is that cobbled stone or that tumbled paver, are those sales as comparable as what they were a couple years back? And the general trend is we're seeing less of the tumbled product in most markets, not all though. There are market segments that the tumbled systems are extremely popular yet. And so we know fashions and fads come and go. I saw somebody wearing bell bottoms the other day, and I thought those are long gone, right? So things are always coming and going. The beautiful thing is you always have product lines to fit that customer's want. Okay, what is that aesthetic trend that they're looking for? And so here's a project kind of in your guys' area where they just use that Barcelona, that long linear look, that modular look, but it's been tumbled, right? So now they get that aesthetic finish of more of a stacked stone and not that chiseled look. So great way, same patterns, 2-course, 2-course light, 3-course, 3-course light. No reason to change. You still have that modular shapes, full size, half length. But you can kind of just see how the Europa changes that aesthetic a little bit more. So it just gives you that old world charm, as I mentioned. Okay. Got a lot of pictures of just the Europa applications like this one. You got the pattern here, but then all of a sudden they got into a real tight radius. So they went into all the half length unit. I think they probably could have brought in some of these little Bordeaux's to kept that pattern in, but maybe they're running short on the pallet. I don't know. I wasn't on the job site, but we know these pattern walls can grow in height, grow in complexity. And what you're going to realize is the block is just kind of that facing of that reinforcement. So we're comfortable with pattern walls being 2 feet tall or 52 feet tall, right? Because it's less about that the face and more about that reinforcement that we have. So you can kind of see here that landscape lighting in here as well. Okay, the last collection I'm just going to touch on, it is the Fieldstone. This breaks away from our traditional Allan block, right? We've got a 2-piece system. We got a facing element and then we got an anchor piece. Now the facing elements are just 812s and 824s, stretched ourselves for a name that way, 8 by 12, 8 by 24, but we got a short anchor and a long anchor. So that gives you the different depths that we're talking about here. You're just going to use 2 anchors for the longer or the 824s when you start developing them. But we got different aesthetics. So the Sierra series is more of that chiseled look. As you can kind of see here, it looks more like that chiseled stone. Here you can see the 824s. We can blend the 812s and the 824s. They're all dimensional. You can kind of see how that stacks out, all in that Sierra series. We do have a colonial option. This is in Chicago, a wild dogs exhibit. Colonial option, which is more of a stacked stone outcropping type look. So it gives you a different texture that way. Here's a wall right outside of our corporate office where we refaced one of our competitors' wall. We couldn't move into an office that had a competitor retaining wall, so we had to redo it, right? So here's that colonial look as well. We even have the ability to do a wet cast face. So since we're minimizing the facing element, we can use wet cast concrete and pour it into a mold. And Reading Rock's got the mold and they call it Heritage. And so it really cleans up the lines because wet cast concrete can take the shape of any mold, so you can see how pronounced those lines are. What is your cost to do though? Think about it. I mean, if they're going to manufacture this, they set the mold up, they pour it, they let the mold dry, let it concrete dry a little bit, then they have to strip the mold, then they set the mold back up, and it's very labor intensive. So your cost of the product like this goes up compared to your dry cast, where it's just that mold's already in place and they're almost just stamping it out. So keep that in mind. If you're looking for a customer or a customer that has a big budget and they want something that's going to pop, you can look at that Heritage as well. But here you can kind of just see the uses of just the different Fieldstone. And this is that Heritage I mentioned before. They came back and stained it up a little bit too. All right, so I'm going to give you some backstories or things to consider as you do your retaining walls. Here we're just looking at a project down in Australia, 2-course pattern for that reinforcement. Obviously, they had a single course on top, so they had to modify that pattern. They're just using the full size there. Aztec, beautiful landscape application. Don't even have to worry about the grid in this case. So you got the full size block, and then they did do a 3-course pattern above. Love this project. This one we've used for educational purposes for many reasons, because there's a huge lesson learned by the contractor. I'm going to ask you this question, and I want you guys to raise your hand if you agree with it. You guys as the contractor are responsible for laying out a wall, determining where the location of this wall needs to be. That is your responsibility as a contractor. And either I have everybody sleeping, or most of you guys are like, the way he's phrasing this, I'm not sure that he wants me to be responsible. So I do have a couple hands popping up. Obviously, on a project like this size, you guys as contractors are not responsible for it, right? Their surveyor or the engineer's representative is going to give you where this location is going to be. But I would challenge you guys, even on homeowner projects, residential projects, you guys are still not responsible for layout. Okay, you might be the ones painting the line, pounding a stake, but who is responsible for that final go or no go? It's the homeowner. The owner is always responsible for layout, always. They are giving you that final location. Before you start excavating, they are giving you that final location. You do not want that responsibility for layout. Why do you say that? Because I've had contractors that are now proud owners of retaining walls because they're not in the right location. They had to discount their price, or they've had to rebuild that wall. And you only get paid to build the wall once typically, right? This particular project, the surveyor came out and located where the wall was supposed to be built. Now this is a land bridge, so there's another wall that looks just like this on the back side. But the surveyor did not take into account the setback. So in essence, he was giving the location of the top of the wall. Fortunately, we had a contractor that was familiar with segmental retaining walls, so they did their own little measurements, taped it off, and like, man, this doesn't seem right, because they realized that if they would have built the wall with the setback, the 2-lane road weren't going to have the sidewalks that they were planned. So they got the surveyor back out, they relocated where the wall was supposed to be at the start, at the base, to account for the setback, and they were able to build this wall. So you guys as contractors, you are not responsible, but I always say trust or verify the conditions. Again, you're going to know more about segmental retaining walls than just about anybody else. I keep coming back to that, because this is something that you're going to be right in your wheelhouse, being able to help make sure these projects are successful. Now, when you're working with a surveyor, those of you guys that do commercial work or Department of Transportation work or something like that, make sure you understand what they're giving you. Are they giving you a center line, face a wall? Are they giving you an offset? That's where those pre-construction meetings really come into play, and take that to your advantage. Here's a nice little Colorado DOT project where they just did a little on-ramp, the Ashlar pattern. Love the fact that I can show this where I've got a 3-course pattern of the wall here, then I drop down to a 2-course pattern down below. I mean, think about this. Where do you think the maximum pressure on a retaining wall is? It's always down towards the bottom. It's like when you dive into a swimming pool, you feel the pressure in your ears the deeper you go. The same thing with soil. So it's not unheard of to have more grid requirements at the bottom of a wall. And so here they have 2-course spacing before they transitioned up to a 3-course spacing. So just keep that in mind. All right, so you've seen this picture already. That's that Florida DOT project. Love this, where the guys are just being very creative, matching almost a limestone on a building with the Aztec, or excuse me, with the fieldstone. Okay, but I mentioned that with the tumbled systems, with the Ashlar patterns, we're okay with some pretty sizable projects, and we are. I mean, I think the tallest pattern wall we have is over 40 feet, near 50 feet in height. These are the two kind of showcasing this, but this 80 classic wall just planted, right? It's all about understanding what the needs and wants are of the customer, and providing them the solutions. And once the wall's in place, you know, with some limitations, you can bring in some plants and stuff on the wall, as long as you're not really damaging the blocks. But the roots are a natural grid when I look at it too. So how do these walls work? Again, guys, I want to encourage you guys to continue to ask questions, especially now when we're getting into how these systems work. And if I say something that contradicts how you've done it in the past, good. That's the discussion I want to have, and I'm going to give you guys the latest and the greatest. What are the trends? What are the recommendations as of December 2020? What you're going to find out is this industry has evolved, and this industry will continue to evolve as we learn more, do more research, have more experiences. And so obviously this is not an Allen block project. We are not that old, but it is just using large blocks or mortarless blocks, because there's no mortar between these as well, and letting gravity take over. And so for Allen block, we're a front lipped bottom notch system. We are hollow core. I'll get into that, but it doesn't require a secondary piece. We don't need a pin or anything like that because of the patented system that we have. But if you're not familiar with Allen block, a lot of you guys are. You've stacked up plenty of it already. This is what it looks like. It's a front lip system. And so when you look at the cutaway cross section, you see that big core in the middle. The wings on the back side give you nice little ways to move it around. But when you stack it up, we just make sure the lip and notch are in contact with each other. And then as you backfill behind the block with your rock, we're going to go ahead and backfill the core as well. And so that way we're getting rock in the core to provide some stability that way. And let me get into that a little bit more. Now, one of the reasons why segmented retaining wall and Allen block has been so successful is because economics. We do not need a concrete footing. Because there is no mortar or concrete in these walls or between the blocks, they are flexible. And that is a huge advantage. We still fight to this day commercial applications and Department of Transportation work where they want to bring in a reinforced concrete footing. We don't need a reinforced concrete footing. We don't need a concrete footing at all. We actually can put it right on top of that granular material, truly like a leveling pad, and then it can flex and move with that ground movement, especially in the northern climates. We got freeze, the frost heave from the soil. That's okay. We can move up and down just like your pavers move up and down with the freezing and expansion of that material. So if you ever work with an engineer and they do call out a concrete footing, what do you need to do, right? You need to put that concrete footing in, or you have us call them and see if we can find out what they really need or something like that. But everything we're going to talk about today are manufacturer's recommendations. If you're working with a designing engineer and they call out for footings and stuff like that, their design are the project requirements. So keep that in mind. We're talking about recommendations today, which is generally what you're going to see. But if you see something on paper that really contradicts what we've talked about today, I've said it a couple times already, you know more about segmented retaining walls than most engineers. Don't tell them that. We're a little sensitive people. We like to think that we're the smartest people in the room all the time. But sometimes they just need to hear it from Redding Rock, or they need to hear it from Allen Block Corporate and have us ask that question going, do you really mean to have shorter grid lengths at the bottom, or do you really need that reinforced concrete footing? You know, sometimes it's just a quick question to kind of reiterate, and it's a teaching moment for us. All right, so but generally we do not need that reinforced concrete footing at all. Now, the lips give us that shear key, provides that connection that we're looking for, but that rock in the middle also provides great interaction between the two blocks, and it helps support and minimize any of that lateral movement as we talk about it. Now with us, I mentioned that if you ever need a vertical block, that AB vertical, you got to work with the team at Redding Rock, because that's a block that is manufactured, which is nice, right? You guys don't have to guess what setback to put things in. You're not figuring out which hole or anything like that. It's already pre-made in the block. So if you order the AB Classic, you know you're getting a 6-degree system every time. No guesswork. Okay. Now, hollow core. Let's talk a little bit about the hollow core. We were one of the first blocks on the market back in the late 80s to be hollow core. Everything is about solid weight, that kind of stuff. And what we want to do is there's some advantages to being hollow. That's why you see Allen block's not the only hollow core product out there. Water is the #1 enemy. Well, if we can drain a little better, we got better drying. If I got better drying, I got a better resistance to that freezing and thawing cycle. And freezing and thawing could actually degrade a block a little easier. Every concrete product out there can go through freezing and thawing, and they might start to spall or scale. Same thing with efflorescence. What are efflorescence? Well, efflorescence are that white chalky residue that could be on the top or the face of the block, and that could be on a paver, a block, a brick facade of a building, you name it. Any concrete product has potential to effloresce. Well, efflorescence comes from the concrete itself, and the water has to bring the minerals and stuff to the face. Well, if I handle the water better, I got better drying, I have less efflorescence. Now, I do want to give you this little tidbit of information. Efflorescing has no indication of the block durability. You could have a paver, you could have a block effloresce every spring. Okay, it's got a little white residue, and then when it starts to rain, it washes it off, that kind of stuff. It doesn't mean every year that block gets less and less durable. Efflorescent has no indication on block durability. It's just the natural material coming to the face of the block, and then it gets washed away. So easier handling installation. That's why you guys might like a hollow core product. Obviously, lower production labor and freight costs is one of the major reasons we do. Now let's talk about water. This is one of my first things that I get to talk about with you guys. Water is your number one enemy. Everything you should do is you can think about where that water is coming from, where is it going to go. Now we are going to provide some in-wall drainage. So that way we can look to see how we're going to handle the water once it's introduced to your system. All right. So you're going to fill the cores in at least 12 inches with that wall rock. We used to call it drain rock, but we're trying to get away from that terminology because far too often we had too many people trying to drain water to this. It's really meant for that incidental. When it rains, we know water is going to come into this a little bit. So we're not trying to funnel more water to it, but it's going to be at least 12 inches of stone behind this. And that's all going to a toe drain. Now that toe drain is usually what? A 4-inch perforated pipe. It's down at your lowest point that still promotes drainage. So we know water is going to come in, and that's being indicated by these red arrows, and gravity is going to take over. It's going to go through this clean, open graded stone, and it's going to try to go through, well, it's not going to go through your wall, right? We got that front lip, but that wall is not impenetrable. The water can come through this, but if water starts to build up, that's where this pipe comes into play. So we always put that pipe at the lowest point that still provides that path of least resistance. Now, 2 talking points here for you guys. This shows a nice little shadow line. Show of hands. How many of you guys put or have put in filter fabric between this clean stone, this wall rock, and your backfill material, which is usually kind of that dirt, that clay, that soil. So a lot of the hands are popping, right? So you see this fabric vertically behind this wall. And why is that fabric being used? Because they want to try to have that separation between your stone and your soil. So that way, if it does come in, you're not contaminating or clogging up your rock. Now, what you might be interested to know is we are starting to see less and less vertical fabric in our industry. And you know what? I'm okay with that. We only recommend vertical fabric when I have like a sugar sand or backfill material that's very sandy, especially some of you guys that might do work around Lake Michigan, Ogden Dunes area. I put fabric in here, right? Because that sand can move, but I don't worry about the sand clogging things up because the water can move in and around. But I also put that fabric in there when I have a water application, and I will talk more about that later this morning. But typically, I don't like fabric, even if I've got that clay material, stuff like that, because I've seen far too often where that clay material comes in, hits the fabric and stops just like it's supposed to, and then the water can come through. But over time, you get so much of that clay stopping, it actually clogs the fabric. And we've seen now you've got water being trapped behind the wall, and that could be a problem. So Allan block, we don't typically recommend that fabric. Even the NCMA, their last design manual, it is up to the local engineer now. So it's no longer a hard recommendation. It's really up to the designing engineer. So it gets back to my recommendations versus requirements again, right? If a engineer puts that fabric in his design or their design, you put it in the wall. You can't call them up and say, well, Chad Julius told me I don't need to do this anymore. I don't like fabric unless I have sandy soil or a water application. But as long as you're handling water properly, I don't usually have to worry about that silting up whether it's there or not. And that's the little asterisk. Am I handling the water properly? Now, similar talking point, do you have a sock around your 4-inch perforated pipe? To me, I don't care, right? I'm not taking the time to cut the sock off. I'm not taking the time to add a sock. To me, I just want a 4-inch perforated pipe at the lowest point, vented to daylight. And that is the key. I gotta make sure that pipe is vented to daylight. We say every 50 feet, center on center. So if you can go in the leveling pads, this assumes you're using that clean stone all the way down and vent it underneath the wall or around the wall, or maybe you're tying it to a stormwater collection system in front of the wall here, perfect. Otherwise, you can do the alternate drain where you just raise that pipe up and now you're coming through the face, okay? One of the dirty little secrets about that fabric was it was put in there to prevent the staining of the block. Well, Allen block, we've got a front lip, so we don't have to worry about the staining of the block. So that's one of the reasons why we've never really recommended fabric unless I've got that beach or sugar sand for backfill or water applications. All right, and then built-in handholds, easier way to move that block around. I always kind of laugh to myself now because I was doing this certification class in Iowa a number of years back. We got to the hands-on area in the afternoon, and the contractor was busting my chops a little bit, wondering where the cushy handholds were for the block before he started taking it off the pallet. Now it's just kind of showing where you can grab the block, and its hollow core makes it easier to move it around. But lower transportation labor for costs, that's why it's right there for us. But there's some huge advantages as why we're using segment or retaining wall. You know, it's not just Allen block advantage. We've got the durability and the versatility to really match any grade change or any site conditions. Because it's hollow core fully engineered, you've got all of the reference material behind you, but the aesthetics are there. What color, what texture, what are we looking for? And it makes it easy to provide that site solution at an economical option. And the environmentally safe we're putting in there because we don't have to worry about the concrete leaching hazardous chemicals or something of that nature. All right, so I'm going to go through this next section and then we'll take our first break. I'm going to go ahead and lower hands here real quick just to kind of make sure I don't miss something. Again, if you guys have any questions, please use that question feature within the GoToWebinar and grab my attention here. Again, I try to make these as interactive as possible just because, you know, you're listening to me the whole time, but I do need that feedback so you guys understand where I'm going from it. But let's talk about safety. Safety to me is the important thing. You know, you guys have one set of ears, one set of eyes, one life. We want to make sure you guys are protecting yourself every step of the way. So safety should always be a #1 priority, regardless of the scope of the project. Fall protection is required by OSHA for anything over 6 feet. Okay, now normally that's commercial, right? I don't see a lot of OSHA inspectors on a residential application. But if you're technically anything over 6 feet would require some type of a railing, some type of a tie-off point. And the reason why I bring this up, again, some of you guys I know are on this call are working on commercial applications. And technically, you're going to need some type of a harness or a railing. And when you do that, that slows your production rate down. And so make sure you read through the specifications, make sure you read through the requirements, and ensure you're not missing something so you don't get caught with loss of production or productivity. Proper safety, like cutting block. You know, OSHA's got the new silica dust rules. That's why you're getting pushed to do more vacuums or dustless saws or wetbacks or wet saws as well. Because really, anytime you see a plume of concrete dust, you're technically in violation. Right? That's already above their PEL, the permissible exposure limit is what that calls. And so when you look at this, you need to have a plan in place to make sure you minimize that dust generation. Safety equipment like goggles, ear protection, steel-toe boots, that kind of stuff. But then calling the utilities, you know, making sure you've got proper locates so you're not hitting those gas lines, water lines, that kind of stuff. I did have a question pop in, and I appreciate that. It says, is the end of the perforated drain pipe capped behind the wall? Again, if you can't vent the end out, it's not a bad idea to cap it. You're just trying to think about where that water is going to go. And so if you leave it open, but it's not vented anywhere, all that water is going to end up going to that portion of the wall or on the edges. So if you can extend it or cap it and force it out through the middle or wherever, so just think about water. You know, where do you want that water to end up? And if you don't want it to end up at the end of the pipe, make sure you put a cap on it. Okay, so I hope that answers your question. Great question. I love that one. But just think about the path of least resistance as you handle these waters. Now, I've already talked about where is the maximum pressure on this wall. It's always at the bottom. Think about that too. I'm giving you a lot of things to kind of consider, but when we talk about how these walls work, it's all about soil. It's all about how it works together. And remember, we've got different setback options because it gives us some different advantages as we go through and work with your natural soil that's on your job site. You could do this experiment out in your parking lot if you wanted to, or your yard. You can drop a load of sand and gravel next to a load of clay. And what you're going to notice is that sand and gravel is going to be higher. It's going to cone up higher than your sand or silt and clays because of that natural strength. The way it locks together, the granular material, that kind of stuff. Us engineers, we've got an actual test that they can run. It's called a friction angle or shear strength, so they can get the numerical value. But in essence, think about what the retaining wall does for you. The retaining wall holds up the soil that's above that wedge. So here I've got clay material. Everything below that line is naturally stable. So the retaining wall holds up this wedge of soil. Sands and gravels, much stronger. So you can see that wedge of soil is considerably less. That's why we really like the idea of building in sand and gravel. It puts less pressure on the wall. It's easier to compact. There's so many reasons why, but we obviously don't have that luxury on a lot of sites. We have a lot of silts and a lot of clays right there on site. Great question again from another contractor where it says corrugated pipe or PVC drain pipe. I am less critical about the type of drain pipe. I do know a lot of times people use that corrugated perforated pipe. It's all the way around. It's flexible so they can match the curve of the wall. Some people like the PVC drain pipe. It's rigid. It doesn't collapse as much. Sometimes it has the larger holes to it, so it's not perforated all the way around. If you're using the PVC drain pipe, make sure the holes are down. All right, it's not up. You're not trying to capture the water as it comes in. You're trying to grab the water as it builds up. So that's why you always put your larger holes to the bottom of that pipe. So for me, I'm less concerned about the type of pipe and more concerned about where it's positioned and how it's vented. So I know I just gave you the worst political answer ever there, James. But for me, I know most people, I'm using a corrugated perforated pipe. It's easier to use. It can roll it out. It's just a little bit easier on a job site. But I do have a lot of contractors that like that rigid PVC drain pipe because they don't worry about it collapsing or getting crushed as easy too. Getting back to your setback, right? Remember we got this 3, 6, and 12 degree options. What does that setback do for you? Well, it just changes the amount of soil that I hold up. So if I got a vertical wall, my center of gravity is straight up and down. I don't have a lot of resistance. So if somebody pushes against me, I could actually tip back and roll over. Well, if I take that and I batter into it, in essence, I lean into this hillside, I change my soil conditions, right? I also reduce the amount of pressure I have behind that wall, and I have more stability. That's why as an engineer, I love our 12 degree system. Absolutely love it, right? Because I reduce the pressure so much more. In fact, if I've got a 3.5 foot high wall, I got 217 pounds of pressure. If I take that same wall but use the AB stones at 12 degrees, I got 160 pounds of pressure. So a 25% reduction in pressure just by changing the block that I'm using, right? So let's dive into this just a little bit more. I'm not going to get you guys to do the engineering, but I think it's important to understand this. It really is my first attempt at driving the design points home to you guys. So I'm just a mix of conditions, 3.5 foot high wall. Look at the wall density though. The block only weighs what, 75, 80 pounds? Well, where in the heck am I getting 130 pounds from? Well, remember, I'm filling the cores. As soon as I fill the cores, now I can take that weight into the equation, which is great. So now my block weighs 130 pounds as opposed to just 75 pounds. So that's huge when I talk about my stability. Nothing above or below this wall, just a 3.5 foot high wall. This equation is just used to calculate the pressure on that wall. So my soil conditions, my batter, right? Remember I said vertical 6 or 12 degrees, that's going to change my setback or change the pressure. But then the last thing is I, which is what is above that wall. So if I got a slope or something, right? I just calculate that pressure. That comes out to be 147 pounds. I want to focus on the resisting. How much can I have for capacity? Well, it is a huge function of weight, the weight of that wall right here. So now I've got 130 pounds per block. I calculate the weight because that is my resisting. And then I just, what my safety factor is, my resisting over the acting. And as long as I'm above 1.5, which means I got 50% more capacity, so here I'm at 1.91, which is great. So this wall is stable just by filling the cores at 3.5 feet, okay? I could do the same thing with overturning, which means I fix the toe and I see if it starts to roll over. Notice I got a little bit higher safety factor requirement because that happens more often. It's more of the prominent method of failure. Think about it. How many of you guys have seen a wall slide straight out? It doesn't happen very often. You see it more overturn. So that's what we do. We check to see what the weight is and what are the conditions around it. Okay, and that's just a gravity well chart. That's all that is. I do want it, you guys, all, because there are test questions. It's going to ask you what is the maximum height of like an AB classic wall in clay soils. Well, if I flip to page 13 of my commercial install manual, you're going to get this table. All right, this one right here. It's going to show you what the different conditions are. So if I look at this, I'm going to have clay soils right there on top. My level condition is going to be my maximum height, and I'm just going to work my way along the top to find the product. Well, 6 degrees, I got 6 degrees AB, the AB Europa. It tells me I can go 3 foot 2 inches in clay. Perfect. So now I can build a wall just over 3 feet in clay without any reinforcement. If I got clean sands and gravels, boy, I like that. I can go over 5 feet. Huge difference when we're talking about, the type of soil you have. So what do you think one of the first questions I have for anybody when they say, hey, Chad, I'm building a wall, what do you think? One of my first questions is going to be, okay, what kind of soil do you have? Do I have clays? Do I have sands and gravels? And when they tell me it's brown, I'm not all that interested in the color per se, guys. I am looking for the type of soils. It's so important to understand what you're building in. And if you don't know, always go a little conservative. Always assume that you got more of a clay material, okay? Now, what also impacts that table is what is above that wall. As soon as I put a slope above that wall, like a 3-to-1 refers to 3 feet over, 1 foot up. So you've got a question in there, I think it might be even your first question, which one's steeper, a 3-to-1 or 4-to-1? You guys know that answer. A 4-to-1 goes over 4 feet before it only goes up 1 foot. A 3-to-1 only goes over 3. So a 3-to-1 actually has a steeper slope than your 4-to-1 or 5-to-1 or 6-to-1. And so we like to try to keep everything to a 3-to-1 or less, so we kind of minimize that back slope on this wall. All right. So how do we build a bigger gravity wall? Well, it's all about weight. It's all about mass, right? So we can take this block, take it upside down, flip it end for end, and we can build a wall that instead of just 12 inches deep, it's 24 inches deep. And that can build a taller wall without any other reinforcement. It's still considered a gravity wall. Other words, do yourself a favor, start getting to understand no fines concrete. That's on page 30 of that commercial install manual. It is in essence stabilized backfill. That's how I refer to it as. So what you're doing is you're pouring concrete in the cores and behind the wall a certain distance. And that is really only about 35% of the wall height. So if I happen to be building a 10-foot high wall, my no fines concrete depth is really only going to be about 3.5 feet. And remember, your first foot is in the block. So you can see how it minimizes that excavation. So that's why whenever you need those special applications, tight site conditions, utilities, property lines, that kind of stuff, one of our go-to solutions is no fines concrete. So the water still flows through this. This is still using that Portland cement, sands, and aggregates, but now you're getting rid of your sand. So the water can flow through this. You don't have the same compressive strength requirements like a permeable concrete. We're not driving on top of this stuff. So your strength is usually around 1200 PSI. So most of your ready mix plants have a mix designed for no fines concrete, but it does not need the same compressive strength as permeable concrete. If they do not have a mix design, work with Redding Rock and they can help you kind of connect the dots. Now, What I don't like about no fines concrete is some of the ready mix plants, they charge you a premium for this. They really shouldn't, right? They got less material, less Portland cement, no sand at all, and so it doesn't cost them any more to make this concrete, but it does mean they got to stop production, maybe clean out the drums, and then make this mix design. So you're paying for that additional labor or setup fee, in essence, what you're doing. But some of the ready mix companies are very good at this. Their costs are minimal, and you can use this as that alternative. But big block, I don't have any problems with big block. I know the team at Reading Rock has a big block option. You know, there's nothing wrong with those large wet cast blocks that you can kind of machine set on a job site. Remember, I just talked about being weight as your number one solution for reinforcement for that option. But we do know big block typically costs more, right? Because you got that ready mix wet cast block, you got to pay for the transportation of that, so your material pricing tends to be higher on big blocks. So we've actually had a nice economical advantage in most markets where we can stack up an Allan block and use this no fines concrete as that stabilized backfill. Now we've been doing this application for well over 25 years down in Australia, where they would just stack the blocks up, and you can stack multiple courses with this, so 2 courses at a time, because we're not trying to compact this. The concrete kind of consolidates themselves, right? So we can stack multiple courses, so 2 courses at a time. And we just go ahead and use that as to stabilize the entire area behind that wall. And it acts more like granular material. That's why I often refer to it as stabilized backfill. So he's walking on it, you got to shovel it, it doesn't pump. Here's a great application. Let me get to this one here, see if it catches up with you here. But when we've got, you know, tight site conditions, maybe they're trying to reface an old timber wall or a natural stone or whatever it is, you can fill that little gap between there with this stabilized backfill, and now you've got a great way to add a better facing to this wall. Now, if this wall is failing, you got to fix the failure first. But if this wall is functioning fine, you can take down a couple timber courses and then bury it and be a nice little solution. But like I said, most ready mix, you can mix this on a job site yourself. You know, it's like a 4-to-1 mix, 4 parts granular material, 1 part Portland cement, you know, water to taste. In fact, if you YouTube and search no fines concrete and Allan block, you'll see a contractor up in Canada. He mixes it on site with a little ribbon mixer that he's got in a bucket of his. But yeah, we're just going to place it behind the wall. You're going to shovel it in place, kind of get it relatively smooth. We do recommend knocking the wings off of a couple of the blocks so you get the no fines concrete on the edges as well. But you can see we're just kind of making sure there's no air pockets, so they're just taking an end of a shovel. But then you just sweep it clean and stack another couple courses and you're ready to go. And we've got so many design tools for this. Like our software has already been reprogrammed to include no fines concrete as an option. But think about it. If you don't have room for grid, which is what we're going to talk about next, if you don't have room for grid, our next go-to solution is usually the stabilized backfill option of no fines concrete, because it allows you to create a mass or weight without all that excavation requirements. So guys, I have got, well, 8:30 my time. I'm a little behind the times for you guys, but let's go ahead and take our first 10-minute break. Okay, appreciate you guys getting back in the seats and continuing the discussion that we have. We went through the programs and stuff in the front end. We talked about some of the products. Now we just started laying the groundwork of how these systems work and some of the solutions that it provides. We just talked about the weight being the important part, and obviously gravity walls just being the block itself with the core fill, and how we can build a bigger gravity wall with no fines concrete as that stabilized backfill. Now we're going to talk about how most of you guys and how most of the applications are working with GeoGrid. And again, this is not an Allan block project. This is the Great Wall of China. But when they started building the Great Wall of China, they would stack the soil up or the dirt up. And what happens when you stack the dirt up? It tries to move out on you. So they laid tamarisk branches down to hold that the rock and the clay and stuff that they had together. And that's really what we're trying to do, right? And we're trying to create that weight to hold back these lateral forces. So this is just a little animation. It's going to show how we're retaining water. Obviously, we're not going to retain water, but if you take that same principle of like that earth dam, that big dam that holds back the water, it's all about that mass. What we're going to do is create that mass by using geogrid. So we use the block as that construction form, and then we put in these layers of grid horizontally to lock that soil together. So we're in essence reinforcing the soil, and it can't move. Well, man, if that soil can't move, it is now part of my retaining walls. So you can see how easy it is to get additional weight to your retaining wall by just lengthening the grid. The longer these grids are, the more soil is reinforced, the bigger mass I have. So like I said, Allan block is kind of that veneer facing, that construction form to this reinforced soil structure. So these layers of geogrid are placed horizontally. It's got to be one continuous piece all the way through. And so that's the dirty little secret. Again, that's why we can build a wall 2 feet tall or 52, 62 feet tall, all with the same block, because the grid does most of the work. So let's talk about how these grids work. So we've got this infill soil, that is the soil in and around the grid. You got retained and you got foundation. Now, we always recommend excavation, and this is basically OSHA standards as well. Always bench cut your excavation for safe purposes, and it does help with the slip arcs or these potential slip arcs and when you bench it out. But we like 2 core spacing, so 16-inch spacing center on center, so every 2 blocks when you're talking about an 8-inch block, and that creates that reinforced mass that holds things together. It's not unheard of to have a little bit longer grid on top, especially when I have a surcharge, which we'll get into, and that can be that additional pressure or that slope above the wall, okay? Let's talk about grid. For as many different types of block that are out there, there's that many types of grid, so many different types of grid, different strengths, different materials. Most grid is made out of polyester, which is more of a cotton based. There are a high density polyethylene, more plastic, but that'll kind of roll out on you, and then you try to roll back up. And so very, very, very strong memory to it. The polyester grid, a little bit easier to work with. It kind of rolls out a little bit easier for you. But they have a machined direction, which that is the strength direction. So most of your commercial available grid is what they call uniaxial, one direction. And so you roll it out, cut it to the design length, put the grid over, move the grid roll over, roll it out again, cut it to your design length. There are biaxial grids on the market. And what I mean by biaxial, it has its strength in both directions. Now you can do what I call the drop and kick. You can run it parallel with the wall. And so biaxial grid is usually smaller rolls, like 3 foot or 4 foot wide, maybe 50 feet long. And then you can roll them out parallel with the wall because they're 3 or 4 feet wide, and it creates that smaller mass. So biaxial grid, because they're lightweight and the limited width, you're talking about smaller projects. It's definitely 6 feet and under, more of a residential application, so lighter loads all the way around. The way the grid works with the block, it's called a rock-block connection. So the granular material in the cores, remember there's many reasons why we fill those cores, helps us lock that grid in. So it's kind of a continuous connection all the way through, where you're talking about a spiral bound notebook as opposed to just different tabs, like a 3-ring binder or something like that. So that granular material falls into the openings of this grid and it prevents it from being pulled out. This is a test that we do as well. Almost looks very similar to what you see on the screen. We take a couple courses of Allan block, fill it with granular material that surrounds the grid, and then we literally try to pull this out. And what we've noticed is that the grid will overstress here before it pulls out of the block. But changing your grid type will change your connection. Okay, think about it. If I got a stronger piece of grid in here, I'm not going to overstress as easy, and actually will help give you a stronger strength, right? And so changing your type of grid changes that interaction, and it's part of the design process that the engineers do. Okay, so the way that rock comes into the opening is the same way the soil does as well. And so all we're going to do is, as that soil comes into this area, it locks together, but as you move away from that layer of geogrid, it loses its influence. Well, that's where that next layer of geogrid comes into play. So we like to try to get multiple layers of grid to reinforce that soil. So I love this thing. This is a nice little experiment for you. I'm going to go ahead, kill the sound on my end, so you guys should still be able to hear me. But this video just kind of shows how this little experiment. So if you want to impress your friends or kids the next time you're building a sandcastle, go ahead and bring in some grid, and you're going to see how you can stack that soil up a little bit and create that taller sandcastle. But here we're just taking 2 concrete cylinders. We cut the bottoms of it so we can use it more like a sleeve, and we're using household screen to act as that grid. I would not use window screen as grid for your retaining walls. It's not strong enough. But you can kind of see what we're doing is just kind of putting in these layers of grid to reinforce that column. And what I like about this is it definitely shows how if it's unreinforced, that soil fans apart. It acts as individual soil particles. But if you reinforce it, now it acts as a column of sand and it can't move. So a great way to show that these layers of grid hold the soil together or hold that sand together, and it adds that reinforcement. So great experiment, a great trick to show how grid works. Okay, so kind of as a review, external stability is all about mass. It's all about, for us, are the grids long enough? So it's all one continuous piece, and it's got to be flat, wrinkle-free, and that's flat, wrinkle-free to the design length. It doesn't mean that you can trail up this side of your excavation at all. It's got to be one piece, flat and wrinkle-free. And this video just kind of shows that external instability where a car backs into the barrier. The barrier didn't weigh enough, didn't have enough mass. And so what we do is we beef this up, and in our case, we're going to add some geogrid layers in there to get a soil reinforcement. And then obviously when the car backs into a larger mass, it's got some problems, right? Now all of a sudden we got to visit the auto body shop. But sliding is important. We check to a safety factor 1.5. Overturning is 2.0, higher safety factor because it happens more often. But then the engineers are going to check a bearing capacity. Let's face it, we're creating this weight here. Are the soils underneath strong enough to hold that up? And then global instability. Global instability is the entire hillside. It's not just the block and the rock and the grid itself. You could actually build the perfect wall, but if the hillside fails, it's going for a ride. And that's really kind of what happened in this application. This is just a small little shoreline along a pond, so it's just outside of the water, but it's only a 4-course high wall. But the mistake that they made is they started to clean out the bottom of this pond. They wanted to get rid of the mud and replace it with some sand. But when they got rid of the mud, it loosened the soil, the slope itself, and the slope moved. So really, that 4-course high wall went for a ride on the soil. So just one of those things as it goes through. Okay, now internal stability is how well does that mass hold together? Okay, so if you roll the grid out the wrong direction, especially if you're using a uniaxial grid, you might lose some strength that way. And so I'm going to go ahead and skip this slide, but we do check that rupture, right? Making sure the grid strength is appropriate and strong enough. We look at pull out of soil and pull out of block. Pull out of block is that connection strength we just talked about, that rock lock connection. The stronger the grid, typically the stronger interaction and the capacity, but the soil, the length is important. So one thing I didn't mention yet is what is the typical length of your geogrid? Well, that's a function of your wall height as well. It's going to be about 60% of your wall height, or obviously what is the design requirement from the engineer. So if I use that 10-foot high wall example, my grid lengths are going to be about 6 feet in length. If it's taller than that, it's going to be longer, right? But that 6 feet kind of prevents any pull out of soil problems that you might see out there as well. And then bulging, making sure you don't miss a layer geogrid. Maybe it wasn't flat, wrinkle-free, that kind of stuff. But this was just, they missed it. You know, I get it. Construction sites are organized chaos, and I use the word organized loosely. Construction sites are very busy. You got a lot flying at you and moving in all directions. And this particular, the contractor just missed a layer of geogrid. They lost track of where they were in the wall and just missed it. And so I challenge all of you guys, take a lot of pictures. You know, most of us all have some type of a smartphone device or something like that, and it doesn't take much to go ahead and take a couple pictures. But you know, as you lay these grids out, you know, have Billy sit there after the first course and you're laying the grid out, say, hey Billy, smile. And he's like, grid number 1, and then 2 courses up, you got your next layer geogrid, have Billy smile, course number 2 and 3, 4, whatever it is, but take pictures as you build that wall, because it's just photo documentation that you're doing it right. You might not do anything with those pictures except for maybe giving Billy a hard time because he was having a bad hair day or something that day, but then you have it. If something happens, you can say, no, I've got grid on 1, 3, 5, and 7. Here's the links. You can see that we got a picture of it. And maybe that's what the inspector can use too, instead of having to have the inspector out there every grid layer. Maybe you can say, can I just take some pictures and send them to you, right? Take a lot of pictures. There's apps all the time that you can upload them to the cloud and stuff like that, so they don't have to be on your personal phone all the time. But take a ton of pictures when you're building these walls. Okay, planning. This is where you guys can use your knowledge and help streamline your projects, right? So I get it. You might not always be able to control where this wall is going to be. The homeowner has it set that this is as big of the patio that it's going to be. This is where that wall needs to be to accommodate that patio. But you can kind of help nudge them a little bit one way or another. Maybe you can see it's a low point. There's going to be some water issues or whatever. So you can help evaluate and determine if that wall is going to be at its best location, and you can give them some nudges all the way through. But then you're going to look at what are the heights, what are the slopes, what are the water runoff patterns, what are the soil types, what are the surcharges, and anything can be a surcharge. We keep showing like cars and stuff like that, but you know, additional snow being piled on top, another terrace wall, even pools, like above grade pools being stacked out, anything can be a surcharge. Now roadways, you're talking more of like a 250 pounds per square foot that comes from AASHTO, or you know, the DOTs. You know, a light vehicle load like a residential driveway, they're going to be about half of that. But again, you might see that longer grid at the top because of that instant pressure, that surcharge, that load right at the beginning of the wall or top of the wall. And it's not uncommon to see that. So you'll see that on the set of plans. Now we talked about slopes above the wall. We try to keep everything to a 3-to-1 or less. One thing I have not talked about yet is how much block do you bury, right? That's the key. How much block is embedded into that below grade? And typically what we do is, you know, about 4 to 6 inches. If you're talking a small little wall, maybe 4 inches, but typically we like a 6-inch minimum, and then that might get more the taller the wall is. So the rule that we have in our industry is for every wall height in a foot, we bury that much in an inch. So I keep coming back to my 10-foot high wall example. If I've got a 10-foot high wall, I bury about 10 inches of block. Okay, and so that would be your standard embedment, and that might change if I've got you know, something below the wall. Let's say I've got a parking lot or something below the wall, and you know there's going to be some construction activities that move this material. You might need to bury a little bit more block so that doesn't become undermined. And that holds true for slopes below the wall. If I've got a slope below the wall, I always try to bury a little bit more block to create what they call a 5-foot bench. So from the toe to the exposed surface, we bury enough block to get that 5-foot bench. Now, what does that do to your price? Your price goes up, right? I'm building a taller wall. I've got additional block because I'm burying more block. So your quote to your customer is going to go up. You have to take the time to educate your customer. This gets back to leveraging that certification that you have. You are a certified wall builder. You can show them, listen, here are the standards out here. This is what I'm going to do to make sure you have no future problems with your retaining walls. You got a steep slope below the wall. I got to bury another block. And if they're getting other bids, which a lot of times they do, you're going to have to advise them, listen, depending on other bids, you might not see the same amount of wall because they're not bearing enough block to satisfy the stability requirements that the industry has set forth. So leverage the fact that you know what you're doing, and teach your potential customer the right and the wrong way and things to look at, because it shouldn't be the low price always gets the job. Right? It should not be that way in our industry, and more homeowners are starting to see that, and quality does matter, and we want you guys to take the quality road all the time when it comes to this stuff. So soil types, we've already talked a little bit about this. Obviously, soil types are important because sands and gravels are going to put less pressure on a wall because of just that natural angle that it has. So 36 degrees kind of represents that clean sand and gravel. 27 is a little bit more of that silty clays when it's all said and done. Ironically, we did some testing for that no fines concrete. That tested out to be like 75 degrees. That's why I tend to call it stabilized backfill, because it's very, very strong. But we just know it puts more pressure on the wall when you've got like that clay material. Now, some of you guys might be sitting there going, well, Chad, you keep telling me that clay is so weak that it puts more pressure on the wall, and you're thinking, has he ever tried to dig in a clay in a hot summer day? And I'm like, yes, I have. In fact, I got a pickaxe at my house for a reason. We know clay has what they call cohesion. So when it's dry, it could be as hard as a rock. But what happens to cohesion when it starts to rain? It disappears. And all of a sudden I got this clay sticking to the bottom of my shoe all the time. And so we cannot take cohesion into a stability calculation. And so that's why clay will put more pressure on the wall, because we assume it's more of a damp or wet condition and not in that dry state. So that's why you'll see sands and gravels will put less pressure on a wall than clay, even though on a hot summer day, a bank of clay will stand almost straight up. Okay, we know water management is the key. As I said, almost 2/3 of the wall problems out there today is because of improper water management. So we've got to take the time to divert that water around the wall. The expectation should not be that it's going to just cascade over the wall like a waterfall. You know, we're going to bring in some berms and swales, and you guys can hide these swales very naturally. You know, you cap the top, 8 to 10 inches, 12 inches if you want, with that clay material that's on the site, but it's graded properly, the water will flow around the wall. So maybe you add a course or two in the middle of the wall, especially if it's a long straight run, and that way you can divert the water around the wall. And yes, we can do some concrete and asphalt, especially on larger projects, but just to get a note, I got a comment from somebody. Ryan, I appreciate this. Thank you. It says, anyone else having trouble hearing via phone call? Lots of static. Please, if anybody else is dialed in by a phone, if you could kind of give me a little feedback and seeing if it's a one-off problem that Ryan is having, or if it's something that is all the way around. But I'll just check my connection here a little bit. I think we're good. Let's see. It says, thought about making a flat, basically based on the block, easier, less measure, but ugly. Hate to interrupt, sorry, it comes and goes on my end. So Ryan, no problem, don't apologize for that. I'm missing, Kyle, I'm looking at this. I thought about making a flat faced basic base block easier to measure, but ugly. I don't know if you can type in a little bit of feedback on that question you just asked, Kyle. I'm not quite understanding where you're going with that, so I apologize. But I'm going to do this, guys. Just for the time being, I'm going to try this. I'm going to kill my my web camera and just see if this helps with maybe some of this. Maybe I'm suffering from a little bandwidth problem here at the office. Maybe that'll help clean up some of that static, Brian, but just let me know or Ryan, let me know if that gets a little bit better for you. Now, if we're talking about water applications, we've got to watch out for those concentrated water sources, those downspouts, things like that. When we're talking about the irrigation lines, some of you guys probably do a ton of irrigation. Be smart on where you trench these pipes. Make sure you don't cut the grid. Let's face it, that top layer grid might only be 8 to 10 inches below grade, and all of a sudden now they're trenching for the irrigation lines, and they could cut that grid, which could be a problem. But again, that wall or that water needs to be handled through surface water, diverting it out and around. And if it's entering the wall, that's where this clean stone, we call it wall rock, and that could be well graded granular material, less than 10% fine. So we're talking about a washed stone. And then we provide that path of least resistance for that pipe at the lowest point that still promotes drainage, or an alternate drain where we come through the wall. And you can cut the block, kind of cut out a square hole. Others is a nice product right in your guys' backyard called Wall Drain Pro. And it's not an Allan block product. It works with just about every system out there. Because think about it, the top part of this is all plastic, so you can cut it to any height you want, but it works perfectly for the Allan block. You just sandwich it between the two units, so it's about 1.3/8 wide, and you can come right through the block and not have to cut. And man, and if you don't have to cut, that reduces your costs, that speeds up your installation. You're not fishing to try to find some type of a screen to put over the top of that hole, because it's built into that Wall Drain Pro. So as a solution, I love what it provides. And so think about trying how to use that. We would just vent that out 50 feet center on center, and makes it a lot easier out there. So we're a nice little system. But we just know if water builds up behind the wall, it's just going to almost double the amount of pressure that you're going to see. So anytime you've got water that comes from like a water table, or maybe a natural spring or something like that. So if you make a cut, you're excavating for your base trench here a little bit, and you see some water, you got to handle that water. And that can be done very easily. A little blanket drain or a chimney drain. Basically, it's more rock and maybe a secondary pipe called a heel drain here. We're just going to bring in that path of least resistance. We're going to capture that water at the bottom point or at the back point here before it has a chance to saturate your soils. That's the key. That's the concept that we're going with here. And this heel drain, when you bring this in, don't tie it into your toe drain. Okay, you want to pipe those independently, so that way if something gets clogged, you're not going to damage both of these. Okay. I did get a question that says, how do you use Wall Drain Pro and keep your setback stacked block in line vertically? Do you have to cut the block? And so when you're talking about Wall Drain Pro, they're 1.3/8 wide. And so Jerry, if I miss your question, just feel free to grab it. But you got to keep in mind with Allan block, it does not have to be on a perfect running bond. I do not have to be smack dab in the middle of the block next to it or underneath it. So as long as the quarter of a block is overlapped, structurally I'm fine. So that's why Wall Drain Pro works extremely well with Allan block, because I can offset it a little bit more and it doesn't have to be in that true running bond. Now, if you're one of those contractors that likes everything to be perfect and you got a straight wall and it's got to be in a perfect running bond, yes, you're going to have to cut a block. You're going to have to make up that 1.3/8. But trust me when I tell you this, you're about the only one that's going to notice that if it's not on a stacked running bond, because you just do it on one course, then your follow-up courses, your second course and above, you could stack it on a true running bond and you'd be set. So you're only talking about the offset to one course, your base course, basically, moving it from that way. And so just keep that in mind with Allan block. They do not have to be on a perfect running bond. It's a nice little advantage for it that way. Again, no pin or anything to kind of line up, so you can just kind of stack it up, and as long as a quarter of blocks overlap, you're set. All right, so we've just taken a break. I'm going to go ahead and push through this one, but we'll take another break here in about a half hour, and we'll get started on some of this stuff. So on the design side, guys, there's a lot of things that you guys get pulled. You've got, modular concrete block. Obviously, that's probably my favorite for obvious reasons, but you even have geogrid wrapped walls. These were used by the forestry industry forever, where they need these temporary logging roads and stuff like that. They would reinforce the soil so then they could create that level pad for that logging road. But when you're talking commercial applications, you got poured in place walls, you got precast panels, you got stuff like that that's going to provide an application, but it's usually going to cost a little bit more. So when you get talking about a modular concrete wall, it gives you a nice little simple solution. I did get a little question here. Says just a block specifically or base layers. If the blocks are never seen, the blocks don't have to have the rough face. Might be easier and
A set of string line. Gotcha. So, Kyle, let me come back to your question as we get into the install side of it. Not a problem. And says, can you provide a 1-inch weep using the block itself or a 1/2 inch? So, if I'm understanding what you're saying, Faraz, is can you provide a little bit of a gap in between the units? You know, if you keep that gap small, do you worry about the rock coming in and stuff like that? You know, what I have a problem with that is we are creating a nice rodent hotel when you have gaps in the block, and so rodents can get in there pretty easily. I do worry about your rock coming through eventually. Remember, your wall rock can be a 1/4 inch up to 1.5 inches, so you can lose a little bit. So I got to admit, most people don't gap it out because a lot of the customers, they see gaps, they don't like it. And so I'm not saying structurally you would have a problem. I think you're looking more of an aesthetic and something you're going to have to explain. And so that's why, you know, a wall drain pro or even a 4-inch square with a cover is acceptable that we're seeing out there. So interesting question when we're talking about that. Okay, we talked about total wall structure. This is the key for you guys. This is probably where you're going to have to explain a lot to your customers because they look at a retaining wall as like a line on paper. They're looking at just the face. And so they might even do some research and they say, yeah, Allan Block's got a 12-inch deep. So I really have about 12 inches, maybe 18 inches of a retaining wall. And they're looking at the property line right here. And you're like, no, listen, I can't build a 6-foot-high wall right on a property line because I need reinforcements. You got to explain that third dimension of a setback and whatever your reinforcement length is, whether it's grid or no fines concrete. That's that third dimension all the way through. Now, setback's easy. You guys can use the setback chart. It's on page 21. And really what I want you to remember and commit to memory the best you can is for your 6-degree system, you're going to be about 1.25 inches per foot. And the way I got that is I just took the 10-foot high and divided it by 10. So it's 1.25 inches. So 1.25 inches per foot for my 6-degree. And that's going to come in, especially when I do stair applications and stuff like that, as you do these minor layouts. Obviously, a vertical wall is going to be 5/8 of an inch. When you're talking about your AB stones, it's going to be 2.5 inches. So you can see on a 10-foot high wall, 24 inches of setback. So that's why, as an engineer, I love the AB stones at 12 degrees. But as a homeowner, sometimes it's hard to explain that they're losing 2 feet of their patio area as well. So that's where that 6-degree really comes into play. Now, you got to be careful. You know, when do you need to pull a permit for these retaining walls? And every municipality is going to be different. So there is no single answer for this, but I do know some common trends out there. Any wall over 3 or 4 feet, they're probably going to need some type of a permit. If you're in their backyard, maybe you get away with it. So I often, when I do these classes live, I'll ask, when do you need a permit? And I might get an engineer or a contractor call me or tell me, say, when I get caught. No, we can be proactive with this. As every state or every municipality is going to have some type of requirement on this. And so be aware, talk to the team at Redding Rock, find out what they are. But the reason why I bring this up is because when you have homeowners that say, okay, I need to pull a permit every time the wall gets over 3 feet. They like to try to do a 3-foot-high wall, step it back a little bit, and then build whatever balance they need, thinking that each wall is under 3 feet. I get around that permit requirement. And that cannot be further from the truth, because if those walls are close together, that is still one structure, okay? And that together is, or that distance needs to be greater to twice the wall height. So if this is 3 feet, this better be at least 6. So 2H, I'm giving you a lot of things to try to remember, and I apologize this, but I don't at the same time, because you're here to learn. 2H is a great thing to remember. That is your zone of influence. Whatever is in 2H, within twice the wall height, that is going to impact your retaining wall. So if you're on a job site and you're working on a 5-foot-high wall, you're going to look at what's within 10 feet of that wall. Is there a parking lot? Is there a roadway? Is there a building? If it's within 10 feet, that's going to influence it. That holds true like temporary construction loads. If I'm building that 5-foot-high wall, I'm going to keep everything back 10 feet away. Now I don't have to worry about that additional loading. So 2H is your rule. That's what you got to check. Now we do terrace walls all the time, guys. We do terrace walls all the time. Some people just like the idea of setting it back, making sure they're not looking at this large structure. They like these little green areas, but these are going to be engineered to handle those additional loads as we go through this. All right, so radiuses. You should know that the tightest radius you can build is about 4 feet. Now that would be at the top of the wall. And so that is the AB Classic at full size, 4 feet here. You can't start 4 feet at the bottom and expect it to fit. So there's a radius chart. So you go to page 57 in your manual, you're going to get this exact same table that we show right here. So the different setbacks gives you different requirements. So if I build a 10-foot high wall, I better have a bottom radius of at least 7 feet, otherwise it's not going to fit. Okay, and if it's greater than that, fine, no problem. Then I've got more room to work with. Now, you've got a question on the second part of your exam, because now we're kind of covering information that would be on part 2. You've got a question that says, what is the radius for a 14-foot high wall? Okay, 14 feet. Well, you're looking at the chart here on page 57, and you're saying, I don't have it doesn't go up to 14 feet. So you got to look at for trends within this chart. Look at every time I move up in 2 feet of wall height, so from 8 to 10, notice my radius. I have to add 6 inches. So in this case, if I got to go up 4 feet, 6 to 8, I'm adding a full foot. So to get to 14 feet, what do you think I got to do? I have to add a foot to my chart or to my radius. So my 14-foot high wall would have a minimum radius of about 8 feet, right? So now at least I know every single one of you guys has one test question correct, because I got an 8-foot high or 8-foot radius for a 14-foot high wall. But when you build these radiuses, pretty simple, right? When we're doing these outside radiuses or outside arcs, we just knock the wings off. We do recommend putting the face down, knock the wings towards the face, and keeps that core intact. When we do these inside arcs, we're just going to go ahead and spread those out, okay? But we would just keep that face nice and tight all the way through. Okay, so let me talk about this. So we're talking about how these walls work, and this is going to kind of set the table for our construction activities. Allan block is the only block that has done full-scale seismic testing. We went over to Japan back in 2002, and they had a shake table, which is this gray thing that you're seeing, a shake table big enough and strong enough that we could build a 10-foot high wall with all the reinforcement and the retained soil. That's what that is being held in by that red frame, and model the Yakobi earthquake. Why the Yakobi earthquake for Japan? Because in 1995, when the Yakobi earthquake hit, it really did a number on a lot of the metro areas of Japan. And so they had all of the research for that event. So when we built our wall, we did the grid, just like you guys would do. We'd put the grid right behind the front lip, and we just built different structures. So structure number 1, we did like three block spacing, 70% grid lengths. Then we did 2 core spacing, 70% grid lengths, and then structure number 3, we went down to 60% grid lengths, but we still kept that 2 core spacing. We did lengthen that top layer G grid. Structure 3 is kind of how we recommended seismic design even back in 2002. And what did we learn? Well, first we learned that these walls work extremely well. They didn't fail. You know, we took it to 0.4 G, which is what we normally design to in the codes, and the wall didn't fail. So researchers, we double the magnitude to 0.8 G, which is like a 7.3 on a Richter scale, a pretty major event. And so when we look at this, the deformation on a 3-block spacing was 3.5 inches. When we went down to 2-block spacing, we went down to 1.5 inches or 1.6 inches. That was the biggest eye opener for us. Now it changed the industry. It changed how the load was modeled. It changed a lot of things about it, but it kind of showed how well this grid works. So here's the top of the block right here. Here's your geogrid reinforced zone. You don't see a lot of disturbance in that soil. Here's where you see a lot of that deformation. Grid works. It kept the soil, the block, and the rock, everything kind of worked as one system. And I'll just kind of let this play here a little bit. This is just structure number 3. In structure number 3, we have that front to back movement, but then we also introduce the vertical component up and down as well. And so you can kind of see the top of the lip going here. We got some target discs being shown with some string lines to see if we can get some major movement in that wall. And you'll see this is the same structure from a different viewpoint. You got bars going across the front of this wall. It's holding deflection gauges. We tried to grease the sides here to minimize any influence that we have from the secondary testing frame that we had to build to hold the soil in place on the 3 of the sides. We mounted cameras on that frame as well, so we got kind of a still point of perspective. So here's that same wall going through that 0.4G, that first shaking. And like I said, this was an eye-opener for the industry. We had a lot of experts expect the wall to fail. They thought the grid would slip, they thought the blocks would separate a little bit, but it showed test after test after test how well segmented retaining walls function. So now this is the same structure, structure number 3, second shaking though. So now this is at 0.8G or like 7.3 on a Richter scale. A lot more movement now. You see this? You can actually start seeing the line on the back of the block, so you know that the soil is settling just a little bit behind this wall, but we still don't see blocks falling off. We still don't see blocks moving per se because everything is still being held in place by that grid. So again, same structure, second shaking, different viewpoint. The only way we were able to get the blocks to move is we had to cut the lips off. So in test or structure number 5, we cut the lips off and did this shaking, and literally we just shook it till it failed. And that's the only way. So it did prove that we need some type of a shear connection. Now for us, we've got an Allan block front lip, so that connection's always there. Love this viewpoint. You can definitely see how much movement you have in that wall at 0.8G. But like I said, great test for Allan block, great test for the industry. It really changed how how segment retaining walls are viewed. It really kind of squashed some of the doubts by designing engineers. Obviously, in high seismic zones, we recommend a 2-core spacing, and it all works pretty well. Okay, so a couple more minutes. Yeah, a couple more minutes, and then we'll take our next break. I'm going to get to the first part of the build section. Building. You're like, finally, guys, it's 10:30 your guys' time, and we're finally getting to the construction of these walls. And really, I'm going to start with compaction, because if improper water management doesn't fail a retaining wall, it's going to be compaction. And so compaction for you guys is something I am going to stress to the nth degree. And why? And I wish I put my camera, actually I'm going to put my camera on right now. This is my soapbox moment. This is me lecturing you guys as the designer or the wall builders. Compaction is 100% controlled by you. 100% controlled by you. You guys determine what equipment's being used. You guys determine how often Billy's going to be running that equipment, but it's 100% controlled by you. And if there's shortcuts in compaction, very often it's because you guys didn't take the time. And so please do not cut those shortcuts. Make sure you compact the soils. And why do we compact soils? Well, it makes sure you minimizes any settlement, right? It gets the strength that you're looking for. It actually handles water better because saturated soils will soak up the water faster. So there's so many reasons why we compact material. So please, please, please do not cut a shortcut, and always ensure you got properly compacted soils. All right, that's my soapbox moment. I'll get rid of the camera so you don't have to worry about that. But how do you measure compaction? Guys, the way you measure compaction is usually a 2-part test. Now, if you're on a residential application, typically the way you're measuring compaction is probably walking on it and making sure it's not moving a whole lot. But a commercial, they're going to reference a proctor, whether it's a standard or modified proctor. But really what it is a proctor test is, here's the mold, so you know the volume of that. And then the hammer is going to be based on what type of tests they're doing. A standard proctor is going to be like a 5.5-pound hammer, and it's going to drop, where a modified proctor, so this is going to be more of a Department of Transportation type specification here. A little bit larger hammer, smaller lifts, so this is going to be very, very dense when it's all said and done. Either way, both tests are trying to give you the capacity or characteristics of that soil. So we start the test with very dry soil, very little moisture content in it whatsoever. Now, what happens when you try to compact dry material? It's going to compact, but you're not going to get that density. So when you add water to the soil, it's going to actually lubricate it a little bit. It's going to aid in that compaction. So your density goes up as you add a little water. Now, at some point, you add too much water and that density goes down. So the Proctor gives you the optimum moisture conditions, and then what is that maximum density that it gives you, okay? That point right here is the key element, because then everything else gets compared to these optimum conditions. So when you're in the field, they usually do like a nuclear density gauge test, and this is what's been done more often than not, so because it's fast and quick and efficient. So they'll drive the rod, they'll hammer a hole, drive the rod, and they'll give you an in situ or in place test of what the soil is right below this device. And it just compares it to the Proctor test. So that's why your specifications usually read must get to 95% standard Proctor, and that's what ours reads, so I'm very familiar with that. That means you need to get to 95% of your optimum conditions. So if you're not there, the inspector might say, no, it's too dry or it's too wet. Maybe you're not on the right side of that curve, or maybe he says, hit it again, the moisture's fine, but you just got to roll it one more time, or vibratory plate compact it one more time to get to that density. Now, what equipment do you use? Well, of course, we recommend vibratory machines, especially in that first 3 feet. We love that vibratory plate compactor. This is a great piece of compaction equipment, but it's pretty violent, right? Maybe good for your base material, but if you're trying to put that in or around your block, it's gonna maybe dislodge it. Now, which one of these is compaction equipment? Please notice I don't even have this even labeled. It's even off in the background. I don't want you to ever think that you can ride on top of this thing with your bulldozer or bobcat or skid steer back and forth on top of a wall and expect to get compaction. It does not work. You actually only compact or consolidate the top couple inches. You don't get that true depth that you need. Now, this one I don't mind. I actually labeled this one for you. That roller, that Ramex machine, especially when you're clay material, great to kind of roll that in and introduce just a little bit of vibration to get that consolidation. Now, can I use something like this? Sure, absolutely. Just don't put it right on top of the wall. Keep it 3 feet back. Remember, I talked about using this as, the logistics is moving the soil, backfilling, compacting. So if you've got equipment to speed that process up, sure, let's go ahead and use it, and we'll go from there. All right, so I do want to take a little bit of a break since I blew through that part one example. I've got 10:30 your guys' time. East Coast time. So let's take a solid 15-minute break. I want you to kind of recharge a little bit, but I also want you to start looking at that test. And if you have any questions, let me know. So I've got 10:30. We're going to come back at 10:45, and then we're going to kind of finish up the build section. All right. So I covered all of part one test and even parts two of that test. So go ahead, take 15 minutes. Grab a little more coffee or caffeine, but we'll come back in about 15 minutes and we'll continue to go through this. Thanks, guys. All right, guys, we're gonna get started again. Appreciate you maybe taking a little break there and also getting started on that test. Again, I haven't seen any questions pop in regarding the test, so hopefully you guys are just killing it. But the test is not meant to really work on your memory, right? It's not there to test if you can commit everything to memory. This is open book, open notes. Let's face it, typically you're not building a retaining wall by yourself, so we can't stop you from working on it together. In fact, we want you to collaborate a little bit on this. So feel free to work on this, work through this test, and get them back to me. You'll hear me close the session with that request as well. So we're going to go ahead and get started on the base material, and it starts at the bottom of the wall, installing that base course. Now, show of hands, how many of you guys like to lay base? And be honest, how many of you guys like to lay base, get down in there, pound that block, and make sure it's done right? And I got a number of hands popping up, at least. Yeah, there we go. Now we're getting a few more. this is to me always a question I enjoy asking, because nobody, it's not something that maybe you think that you're going to enjoy, but let's face it, there's something to be said when you got a job well done. You can look back and it's nice and straight or nice and following that curve, whatever it is. But those of you guys that have their hands up probably recognize that the base course is the most important part. Anything that is done improperly, whether it's not on the right line, maybe it's not level, is just going to get magnified as you continue to build that wall. So I appreciate that the feedback there a little bit. But as far as your trench, so remember, you do not need to put this on a reinforced concrete pad. This can be right on that same granular material that you use to fill the cores and behind the wall. I know some of you guys like to use more of a crushed rock, and that's fine. Then you just wouldn't put your pipe in that rock. You move it up kind of like that alternate drain detail. But the depth of your trench is going to be about 6 inches of rock plus whatever embedment depth you have for your block. So that's the entire depth. Now the width, just add 6 inches to both sides of your block. So Allen block, we're about 12 inches wide. So you add 6 inches. So that's where that 24-inch width usually comes into play. So we go 6 inches on both sides, 6 inches deep. So you got a 24 by whatever depth you need based on your embedment. But everything needs to be recompacted. Now this kind of shows a trench that's as wide as the bucket, and that happens too, I get it. But they're using that same wall rock, that same clean stone as that base rock material, and that's okay. If you need to bring in a little bit of a crushed rock, just move your pipe up. But everything needs to be recompacted. I cannot emphasize that enough. Anything that is soft, loose, if you're in excavate for that trench and you got some soft material, you got to dig a little bit deeper. You got to get more rock in there. You got to firm that up. You can even bring in some grid in there in that base trench to go ahead and firm that up, because what does grid do for you? It holds things together. So you could actually bring in a little bit of a grid to bridge over some of that stuff. And then what we're going to do is just use those laser levels. Everybody's got them for the paver work and stuff like that. So we're just going to go ahead and get that laser level in, get that base trench as level as possible. The more time we spend on this base trench, the less time we're going to be sitting there pounding block. And so a lot of you guys probably have a couple people on site as you're doing your base course. You maybe have 1 or 2 guys, because if you can start in the middle and work away from each other, you can lay base twice as fast. Otherwise, you might have 1 guy pounding the block, but the rest of them are staging the block, getting it close, and then maybe another guy is getting that base rock compacted and level as possible. And so just being smart on how you stage this will speed things up too. Now, I did have a question for earlier today about a different block used for base. And we see that with competing systems, especially if they're a rear lip system, because the rear lip would protrude down into your base, and that can be problematic. Now, Allen block, we're flat on the bottom. That bottom notch doesn't protrude down, right? So we haven't found the need to have a secondary block, because think about that. If it's a secondary block, yes, it's non-aesthetic, right? You don't have to split it. Doesn't matter what color it is. Most of the time it's buried, but it's still a piece that's manufactured. It's still a piece that is that's inventoried, and so the distribution points would have to have a secondary block. And so we've found that it doesn't really cost or save a lot of money or time by having a secondary piece. I'm not saying you couldn't use it. I mean, if your team is out there used to laying a base block, you could use that with Allen block just as easy, So, but for us, the block being that hollow core is one of the easier blocks to level, and you don't have to take my word for it. Give it a shot, and if it works well for you, you're going to use it again. But it's one of the easier full-size blocks to use, and you work through this, and you can just kind of put that string line on the back of the block, because let's face it, the front is split, so you're going to have some variances there. But if you put it on the back side of the block, then you got your straight edge as you go through this. Now, I did have a question pop up. It says, what are your thoughts about building a wall on top of a gabion, such as a waterfront applications? Gabion walls are a little bit different, and we'll get into the water applications and waterfront beachfronts a little bit, but with gabions, I don't mind a little bit bigger rock in your base, especially when you're talking about water applications. But the hardest part of putting it on top of an existing wall or another wall is, are we comfortable with the footing that it's going to provide for your new Allen block wall. And so that's the old caveat I always have with this is, okay, yeah, gabion walls are all rock. It might not move around, but how competent is it? Is it going to move a little bit? And so that's usually the follow-up question I have. How long has it been in place? What kind of settlement have we seen over the time? How do we make sure it stays level so it's not going to undermine or be a problem for your future Allen block wall? And Mark, if I did not hit your answer correctly, fire off another one, and we'll continue to talk about this. But as far as laying base, guys, it is just down in the trench, one block at a time. I like where he has this level. Notice the level is not on top of the lip. I'm not saying that's the wrong spot for it, but the next Allen block does not sit on top of this lip. It actually sits in the meat of the block. So get your crew in a habit of leveling the meat of the block. Put their level right behind the lip, front to back here, and then you just level that up. Notice how he's keeping that string line on the back side. And then when you do this, all you're gonna do is backfill behind the wall with your clean stone in the cores, and then behind that 12 inches, you can usually use on-site soils, right, that approved soils. Run that plate compactor right behind the block going into your hillside. Always think about starting at your wall, going into your hillside. It's kind of like, I guess, squeezing a tube of toothpaste. If you move toward the hillside towards your wall, you actually move a little of the material towards the wall, and you could actually get a nice little bow in your wall if you do it over and over and over again, especially on taller walls. So the proper methods of compaction is start at your wall, going into your hillside. And you'll notice that once you compact, the things will settle a little bit, or the rock and block and stuff will settle, but don't put those levels away once your base course is in. Even if your base course is done, make sure you got the levels in there. Shoot, I did get a note. Can you guys still hear me? Show of hands, raise your hands if you can hear me. I did get a little note that, all right, they're popping up. So for us, just double check. All right, perfect, you're on now. Okay, I'm gonna just lower the hands here real quick. So the next question I don't have anything, but keep those levels handy. Don't put them in the truck. You got to make those minor adjustments in each course as you see it. Maybe you need to raise it up a little bit, that kind of stuff. Don't let this any kind of I guess shimming or anything like that. Make sure that doesn't compound the problem, because it's only going to get worse the more courses you stack. So make those minor adjustments as you go up in the wall. Okay, so I'm going to let this video play here real quick. I'm going to get rid of that topsoil, stockpile that for later for your restoration activities, but we can't build in organic material. Organic material will decay over time, and that's going to settle. So we got to get rid of that topsoil. But then we excavate for that trench. Make sure that trench is competent. If there's any soft spots, it's got to be over excavated. Get a piece of grit in there, get some more rock. Then we're going to go ahead, get your rock in there, and then you compact it. So that way we can get that base nice and firm. Here we're going to show, obviously there's some immediate steps here that we're not showing. We've got to make sure that is level. Then we're going to bring in our string line on the back side, and we're going to level that block up from front to back, right to left, using that persuader or those dead blow hammers as you go. And then as you move through this, you just got to level the one block next to it, and you just go one block at a time as we go through this. And I wish it went this fast out in the field, but obviously that is not the case. And then you backfill, excuse me, you backfill the cores behind with your clean stone, and then your on-site soil behind that. Run your plate compactor from the back of the block towards your hillside. Did get a question, what do I recommend for shimming? We are finding that to shim every 4 feet at least. I hope you're not shimming every 4 feet, but to be honest, the shimming material I recommend or see more often is just asphalt shingles. And I kind of chuckle because I know a lot of landscape wall builders, they go dumpster diving when there's a hailstorm. They got a lot of people that get new roofs or something like that. It doesn't have to be new asphalt shingles. So asphalt shingles are about 1/16 of an inch, and they don't decompose over time, and you can tear them to whatever size you need. So I got to admit, I tend to use a lot of asphalt shingles or recommend asphalt shingles, but anything that doesn't decompose over time. So I don't like wood shims or anything like that. I know guys that use pennies and coins and stuff, and that's fine. But if Paul, if you're shimming every 4 feet, that could get a little bit expensive if I'm putting a coin in there all the time. But asphalt shingles is usually my go-to as I go through this. I did get a question about the size of the plate compactor. Boy, great question. I usually go to a hand-operated plate compactor. Try to keep the centrifugal force. That's the key. The centrifugal force to about 5,000 or less, especially if it's on top or near the wall. Obviously, heavier equipment, bigger plate compactors can be used behind that, but that's just kind of an industry recommendation, trying to keep it more of a smaller plate compactor towards the top of that wall, if that helps. Interesting. So you're just having, Paul, you're just having some problems with the 4,000 square foot project, but touch base with the team at Reading Rock, and we can go through some of that stuff too. This picture is where I usually talk about you do not need it on perfect running bond. In fact, you can see it's offset just a little bit, but as long as you have a quarter of the block overlapped, you're in good shape, as I mentioned before, and that's where that Wall Drain Pro comes into place. Now, when you're doing your next course, we just sweep it clean, get the excess rock off the block. Obviously, we can't have that on there, other than that's a shimming issue. And then I like sliding the blocks in place, so that way we're kind of grinding off a little bit of that concrete slag. It is natural when you do manufacturing that these molds strip up, and so a little bit of that concrete on the edges kind of feathers up a little bit, and that's just part of the manufacturing process. But by sliding the next block in place, you can get rid of that. Sight down the wall, make any minor changes, and then because of that plate compactor size, I like running that plate compactor right on top of the block. And if you're familiar with Allan block, this has been a recommendation since almost day one. We want to run that first pass of that plate compactor right on the top of the block, so that we're consolidating the stones in the core as well. It just builds a better wall. If you have not tried it, please give it a shot, and that way you can go ahead and build a better structure, because the rock will consolidate and locks things together. Now, when we're talking grid, a biaxial grid is going to be lightweight. And this is kind of that landscape literature that's also attached as one of the handouts. But this is going to be for walls under 2 feet, and normally these biaxial grids comes in smaller rolls. Here with Allan Block, we partner with a Strata Grid company, so we do have a grid that's packaged with the Allan Block logo on it, but it's not an Allan Block product, but it's 3 feet, 4 feet by 50 feet long, and so you can just roll it out parallel with the wall. Now, being biaxial, these are smaller projects, under 6 feet. Every 2 courses, we try to get that first layer of grid right above that first layer of block, because where is that maximum pressure? It's at the base of the wall. So every 2 courses we go up. So if I happen to build a 4-foot high wall, you probably look at the chart, it's going to tell you you need 3 layers of geogrid that are 3 foot long. So you just grab the 3-foot roll of grid, and then you just go every 2 courses, you got your 3 layers of geogrid, and by the time you're got your next 2 courses up, you're about 4 feet tall, right? And so that's how you use biaxial geogrid. You can roll it out. Now, on bigger projects, obviously, bigger projects, bigger toys, moving more material around, you are going to be using uniaxial grid, plain and simple. That's just the way it goes. So you're going to need that heavier strength of grid for that bigger projects, and that is something that you roll out and cut to the design length. That is the key. You're going to roll it out. Now, these roll widths are usually like 6 or 12 feet wide, and so you're just going to roll it out, cut it off. And we have design tools and estimating tools for that. But like I said, 60% every 2 courses usually kind of funnels into what our recommendations are. Now with grid, you're going to hear me, my buzzwords for grid is no gaps, no overlaps. I don't want any gaps in my grid, and I certainly do not need overlaps. Most of the time, the grid companies say that grid on grid is a little bit more of a slip surface. You don't get that same interaction. So when there's that overlap, we got to get a little soil between there. So that's why you'll see when you have grid side by side, we just butt them up. We don't have to overlap it. It's not like you need that additional coverage. So here you can see we put the layers of grid down. You might stake it if you need to. Like I said, some grid has what I call the memory to it. It tries to roll back up on you. You could do the same thing by getting a little dirt or rock or something on top of here to prevent that from moving. Because the big thing with grid, it's just flat and wrinkle free. You can see this, the grid's not under tension, but I do like the fact that they're not walking on the grid They're not trying to drive on this grid. They're trying to protect this as they go through, right? And so here's another picture, same project, where they just got the soil being kind of backfilled on top of it, and then they're just making sure that they're protecting that grid as they go up. Now, remember, it's always compacting in lifts. You cannot, even though we've got maybe a 2-course spacing, so 16 inches, it's not like I can stack those 2 courses and throw 16 inches of material between there. It's almost impossible, virtually impossible to get compaction in 16-inch lifts. Even with those big rollers, the maximum soil you're going to be able to compact is usually around 6 to 8 inches. And so we've got an 8-inch high block. That's why you'll see, if you read anybody's recommendations, you're going to see that everybody tells you to backfill and compact every course or every 8 inches. So that way it can go, you can get that consolidation. And like I said, in the first 3 to 4 feet, we want that hand operated equipment, but behind that, we can go through this as well. All right, so we just want to run that plate compactor on top of the block, get that rock to consolidate. I did get a note saying on the second course and above, they had some issues maybe with the gravel material getting compacted, so a hand tamper or something like that has worked well as well. But let me just kind of reread this question real quick. But it says, instead of running a plate compactor over the second course or block, I have always just compacted with gravel inside the block with a hand tap. Is this method better or worse? Yeah, great comment. I'm not saying it's better. I'm not saying it's worse. The whole point of running this plate compactor over the top is to consolidate that stone. If you can do that with a hand tapper or something like that, you're still accomplishing it. It's a little bit more efficient to get to that plate compactor because that vibrates the block and stuff too. And so if you start right on top of the block, you minimize any kind of overturning and stuff like this. And if your base course is level and true, you should have really minor movement of any of the blocks itself. So every time I do a training, when we do the hands-on, I always show the plate compactor on top. You're not going to crack or damage the block. It is probably the faster way to run that plate compactor over the top. But as long as you're making sure you got complete consolidation and getting that stone in there, perfect. All right, that's what we're looking for. So here's the grid. We're going to cut those grids to the right length. Again, uniaxial grid, we got to roll the grid out, cut it to the right length, get another piece where we're just going to go side by side, no gaps, no overlaps, get that course of block over the top, and then we're going to pull that grid, make sure it's flat, wrinkle free, stake it if we need to, but then we just go ahead and backfill and compact. And you can see we just do those same processes. I just get another question, says I usually sweep the gravel off the block after compacting. It avoids bouncing or chipping on the block, or chipping of the block. Yeah, one of those things that I always recommend is when you, before you run that plate compactor, you fill the cores and behind with that clean stone. I just use a square nose transfer shovel. So I just kind of scrape it off. It doesn't have to be perfect. If you have one or two pieces or a couple pieces of rock on here, no big deal. But what you'll find is it'll pulverize the rock before it breaks the block and stuff like that. So I just kind of clean up the top of the block a little bit, but by no means do I need to sweep it per se. But guys over there, if that works for you, I'm okay with that. And so if you've got a process that you got a quick and easy way to cleaning this up and then running that plate compactor over the top, that's fine. Generally, I just kind of scrape it somewhat clean with that square nose transfer shovel and I'm in good shape. What you're gonna find, guys, and this is why I have this picture in here, by running that plate compactor over the top, you're gonna get that rock to drop a little bit, and it makes it easier to clean up. I can consolidate this, I can sweep it clean. I don't have to top this off. It doesn't have to be level. In fact, I like the fact that it's down about a ½ inch because then the next rock comes in, it kind of locks that together a little bit. So it just consolidates that stone, but it's all about compaction. So the first 3 to 4 feet, we're using hand operated equipment. We got to keep heavier equipment off the wall. But in that compaction zone behind that, yeah, I'm not going to use it as a huge haul road or something like that, but I can most certainly use these larger rollers, right? It's all about speeding up this process to ensure I've got better compaction. So if you've got the equipment to speed that up, sure, use it. Just like I said, be smart about this. Okay, let's talk about some of the construction tips that we have out there. And I'm going to really focus on the grid. Now, these grid details are good for just about any block that you use, and I hope you use a lot of Allan block, don't get me wrong, all right? I keep coming back to my buzzwords. No gaps, no overlaps. So when I do these inside radiuses, you're going to notice that grid is a rectangular shape, so it's going to start to fan out on you here a little bit. All you need to do, mark where that happens with a little chalk or soapstone, and then put a layer of geogrid over the top of it. So if I were to look down on it, I got 100% coverage, so that's the no gaps, right? So no gaps, no overlaps, and I'm keeping some material between there, so I don't have to worry about that interaction. Now on the flip side, when I have that outside radius, the grid is going to start to overlap. So all I simply do is lift the top piece up, get about 2 to 3 inches of dirt or rock in between here, and then I put it back down. I do not need to come back and cut it. In fact, I do not want you to come back and cut it. I want that length continuous in both directions, but I just want a little bit better interaction having the rock and dirt between there. Okay, so that's the no gaps, no overlaps in the curves. When I talk about these inside corners, so here is the block facing of this inside corner, I just make sure I need to extend the grid into this corner. And now this is a uniaxial grid because I'm seeing a nice thickened edge of that edge of the grid. So it tells me that the strength is this way or that way. I just go ahead and extend the grid into that corner at least 25% of the height. Now, a lot of times the guys are going almost to the length of this following grid, but the minimum is at least 25% of your height of your wall. Now, on your next layer of grid, you can see the strength is this way. I just extend it going the opposite direction. So I kind of, in essence, kind of zip that wall together by going at least a quarter of the height going into that inside corner. Now, outside corners. Keep in mind, it all is based on your grid. Now, if I have a biaxial grid, it doesn't matter. I can come into the corner here and I can start my grid going that way because the strength is in both directions. Now this is showing, I got that machined edge again. This is showing that uniaxial grid. So my strength is this way and not this way. So technically this is the weaker point. I got about half my strength. So what we try to do, this is part of the best practices and working with designers, but you guys can make these minor adjustments with the approval of the engineer. Please do not make any changes to their design, like field changes to their design. If you change or deviate from their design, you are now the proud owner of that design because you're not following their site requirements. So any change you make needs to be in writing from the designing engineer. But what we try to do in outside corners is we come in the corner on like the odd courses, 1, 3, 5, 7. But we'll leave the corner on the even courses, 2, 4, 6, 8, and we'll just change the orientation of that grid so we've got strength going in both directions, which is perfect. That's exactly what we want because that way we've got a nice reinforced outside corner, which could be a potential weak point in the wall anyway. You got two corners or two walls trying to go in opposite directions. So we love getting a little bit more grid in this outside corner for that reason. Now, anytime you do turn-ins, a lot of guys like to peel the wall off a little bit or create these little planter pockets, and that's fine. I don't have any problem with it, but again, keep in mind what you're doing. You are creating another wall, which means what does your footing look like? This gets back to whose question was it about the gabion walls? You know, what if I build on top of a gabion wall? You know, is this something that I can handle? Well, what does that footing look like? Do I have enough capacity there? You know, and Norbert, I just saw your note on this, and I apologize. You're exactly right about the base material. You know, if you're building with an Europa wall or something of that nature, there's no reason why you have to use a Europa or Aztec or anything like that, something that's a little bit more money. You could come back and build your base course with your classics because that is buried, right? So you could do your classic down here and then transition to your Europa or Ashlar or even your Aztec wall because now that's where your money is. That's where you see it. So that is a great point. That is a great question. Actually, not even a question. That was more of a statement from you. So no, I appreciate that in general. But you notice if your footing on these upper walls are not correct, you'll see it start to drop, and you can look real close right here. You got a little bit of settlement happening just because that footing wasn't properly maintained. And that holds true. Let's get into your pattern walls. Kind of gets back to what Norbert just said, right? Or just talked about. You know, when we do a pattern wall, we're going to run that plate compactor or consolidate the stone as we go up, but we're only going to run that plate compactor when we've got that horizontal line, and that horizontal line also adds that grid and stuff like that. But you can see we're just going to use the classics as your base, full-size units, keep it simple, but then we're going to use grid if needed, but then we're going to build about half your base. Still always think, excuse me, half of your pattern, but still always think about backfill and compacting in 8-inch lifts behind here. And then obviously when you finish your pattern, then you're on your plate compactor over the top. So we try to make sure you got rock all the way through these cores. Now, those of you guys that like to lay base, you've definitely understood that much easier to do a step up than it is to do a step down. So as you build your wall, try to find the lowest point in your base and start from there, if at all possible. So that way you can backfill compact, you can get your first course of block in there. We always recommend trying to extend your rock or block at least one full block in here before you do your step up. That way you don't have to worry about undermining of your wall in those sloped areas. But then you can use the height of your block to help level out that next portion of base right in through here. So always try to do a step up and not a step down. Now sometimes you can't avoid it and you're just going to have to do those step downs. Now ending your wall, again, these are construction tips and tricks. Ending your wall, it's really up to you. You know, you're working with your customer. What is it going to look like? You know, some of these GRS, IBS applications or major roadways or even commercial work, they don't always care about what that end looks like. So sometimes you even see the side of the classic and they're okay with that. But other people, especially residential applications, when the homeowner's walking past it 2 or 3 times a day, you might use a corner, you might feather it out. I know guys that use the half high unit, kind of showing that here. Love this idea because now you're doing 4-inch step ups instead of 8-inch step ups. So you can just do that half high unit. And that's where that light stone or junior lights come into play. But don't be afraid, especially on, you know, these landscape applications where you use that lip as that leading edge. And you can use that as kind of that edger for your mulch or your rock and stuff like that. And it really extends the look of that planter and it saves you money. So that's might make you the low bid. And I just told you that you don't always want to take the low bid, but if you're smart about it, you're selling them on the idea that, hey, we're going to expand the look of your planter bed and we're just going to use that lip as that edger. You can do that. We do that all the time. Now you don't have the cap. Now you don't have to come back and cut the cap because let's face it, if you do a lot of curved walls, you're cutting caps where you're taking these rectangular shapes. And to do it right, I always say you cut both sides of the cap so that way your front and back of that cap line up all the way through. Okay. So talked about these inside and outside corners with grid. Let's talk about the block real quick. I want to stay on the grid patterns since we were talking about no gaps, no overlaps. But when you talk about block, the only time you'll ever hear anybody from Redding Rock or Allan Block tell you to remove or modify the lip is on these inside corners. And all you're going to do is remove the lip that is buried. Okay, so that way the next block or next course can go over the top of it, and then you just alternate which side that you remove. Okay, I do recommend scoring the block or maybe even cutting the block so you got a nice finished edge all the way through, because if you look real close to that inside corner, you can see into that a little bit, but technically it's buried. You could just hammer and chisel it off, whatever you need to do. Now, outside corners, we do have a 90-degree corner block, which means it's got a split face on both sides. There are rights and lefts, and you just alternate those as you build this corner. But when you build a corner, you just stagger them, all right? And you're gonna see that it doesn't get you on a perfect running bond pattern. But again, remember, you don't need that for Allan block as long as you got a quarter of the block overlapped. I am gonna give you a little tip about these outside corners. Don't make your cut right here or here, okay? I guarantee you're probably gonna have to cut a block lengthwise as you work into the corner. You got a fixed point of return, you got a fixed length of block, something's gonna give. Always make your cut maybe 2 or 3 blocks away So as you build into this corner, you're going to kind of come in, you're going to know you're going to have to make a cut. So maybe you measure this, cut it to 15.5 inches, whatever it is, right? But then slide 2 blocks down and put that cut piece 3 blocks over. Why? Because everybody's eyes go to that corner. And if you have a cut block right there, they see that. Or if it's simply 1 or 2 or 3 blocks away, they'll never even hardly even notice that a cut was made. And so just a level of professionalism, especially on these residential applications when you're really trying to hammer those aesthetics. Okay, now steps. I wish I had I wish I had a tip and trick or the silver bullet on every stair application that we have here, you know. But these are kind of fill steps where they're just filling in front of a wall with some curves or maybe even a rectangular shape. You know, these are parallel steps. They kind of parallel along the side of the wall. You just do some inside and outside corners to kind of create these. These are perpendicular steps going into the hillside, so you're cutting into the hillside. Obviously, I see guys cut into the hillside and put some in front too. So every stair application is unique. And we get a lot of questions. I know the team at Reading Rock are probably shaking their heads going, oh yeah, we get a lot of stair questions because they are unique. The biggest thing that you need to keep in mind is that the stair is going to be your 7 5/8, right? It's going to be the height of the block. The tread is what you guys need to consider. Is it just the cap? And so you're going to go up pretty quick. Is it going to be cap and some pavers so you can feather that out a little bit more? So as soon as you know your tread depth, now you understand how that step is going to be laid out, because that's the critical distance. Now, don't get cute with the rock. It's easy for me to do this in animation and line art. You're going to oversize or use a lot more rock in these stair applications. Please just use a lot more rock, because this is a traffic area. This is where people are going to step. You might get some differential settlement. I love grid. In fact, I am starting to hear more and more people say it. So please, I hope you start. I often refer to grid as like Frank's Red Hot Sauce. You guys hear that commercial? What do they do with Frank's Red Hot Sauce? They put that on everything. And I won't swear, but I know I probably won't offend too many people. We put that stuff on everything. I like the use of maybe even some biaxial grid in these stair applications, because then it holds those stairs together. It acts more like a staircase and not as individual steps. So that is much more of a belt and suspenders approach. But again, I'm minimizing movement, and that's a good thing. And so we know grid works. And anytime you do these perpendicular steps, you are going to get a setback, right? And you see these in our pictures and stuff like that. Every time you go up, it's going to step back. So your stair is going to grow in length. Now, if they don't want that, that's a cut. Then now you're going to have to go almost near vertical here. And the way we would recommend to do that is deepen the bottom notch. Remember, don't ever mess with the lip. So you deepen the bottom notch, and that allows you to pull that block forward. But that's a cost, and that's something that they'll have to pay you for. That is not something you just donate your time and money to do. So with stairs, it's all about making sure you get that on the level plane, make sure you get they're level to the ones next to it. So with stairs, it's just a lot more base. Now, things to keep in mind, some of the tips and tricks, right? You know the height, you're going to know your tread depth, how you're going to finish that, and you know your setback. Your setback is 1.25 inches per foot for that 6-degree system. With that, you guys are going to be pretty clever enough to figure out how to lay that fence, those stairs out. So I'm going to go ahead and skip these animations, because what I want to get into is with anytime you do stairs, more often than not, you got to worry about some type of a railing. And sleeve it is the best engineered solution you have, because if you're not going to use sleeve it or reinforce the face of the wall, you need to keep it back 3 feet. Well, who wants to keep a railing back 3 feet? Now all of a sudden I got more of a maintenance issue of who's going to cut the grass or whatever on the other side of the rail. So to try to tuck this railing up by local codes, I got to look at what this additional loading does. And so very often a retaining wall triggers the need for that railing. And so Sleeve It was invented by a contractor. You know, his story is that he, you know, did it shooting hoops with his kids. Obviously, he has this cantilevered footing on a basketball hoop, and everybody sees this in driveways and stuff like that. But it prevents the basketball hoop from falling over. And his son, who's was only 40 pounds at the time. Obviously, this is a pretty old picture. I think Noah's in college now already, but you know, he doesn't need any additional weight on this basketball hoop. Now, his older boy, a little bit heavier, needs a couple Allen block here. Otherwise, this basketball hoop would fall over. So these railings are designed to keep things from coming over the top of the wall. This is not a staged picture. This is our fearless leader right now, our current president, Tim Bott, went up and over his wall when he was mowing the grass. Not sure what he was thinking that day. He did make a comment about not spilling his beer when this happened, so that could have been a leading cause. But we just know Sleeve It is a great, simple solution. It satisfies the code, and what it does is you can tuck it up right behind these blocks, because this is about 12 inches in diameter, 24 inches tall, and now you can go right behind the block, and you can still do your backfill and compaction activities. But now the fence guys, and maybe that's you, maybe not, the fence guys can just hammer the cap down, fill it with concrete, and bring in their railings about this. All right, so very simple solution. You cannot just anchor or glue the railing to the top of the cap. It just doesn't work. There's not enough resistance. There's not enough overturning resistance. So I've seen guys reinforce the top of the wall with some concrete and steel. I've seen them add more grid, but the most simple, the straightforward solution is using Sleeve It. And again, it's not an Allen block product. It works with all of the retaining wall systems out there. All right, did get a question about this. Do you glue the caps? Great question, absolutely. We definitely want to glue the caps down. It is non-structural. So keep in mind, caps are all aesthetics, all right? So it's non-structural, but we do recommend gluing the caps down. For some reason, that 75-pound cap tends to grow legs. Either kids like to move them around a little bit, but we do recommend gluing them down. But as far as a Sleeve It system, this is something that you can add on to your services, but it's got to be arranged in advance, because you're building the wall, you're moving the dirt, you're moving the block, so you could actually get paid to help do the fence footing. So just coordinate as part of those pre-construction meetings, find out what the center on center spacing is, and then as you build the wall, you can bring in this Sleeve It. And again, like I said, get paid to do this, and then the fence guys can come in after it's been built and bring in the fence system. So the fence guys, what they like to do is say, no, we'll take care of the footing, and then what they like to do is try to auger through the grid. That's not good. You cannot auger through the geogrid. It'll tear the grid, it'll damage the grid. Now all of a sudden they're gonna have to come back and pay you to rebuild that wall. And sometimes that's good, sometimes that's bad. Remember, you usually only get paid to rebuild the wall, or paid to build the wall once. And so the second time, there's usually some fighting involved. So be proactive. Find out if that railing or when that railing is going to be required, and maybe even recommend the Sleeve It system, so that way you can have a nice little add-on sale there too. So great question. Actually, I had a comment there, who's responsible for the install of the Sleeve It itself. The responsibility is ultimately the owner, but you guys could actually assist in installing it as part of your scope of work. But it's all coordinating with the design team, with the fencing contractors, and that's part of those pre-construction meetings. Now, that's on a commercial application. Residential, you're going to work with a homeowner. You're going to know that they're going to need a railing. You're going to ask them what type of railing they're going to use, and then you just know that center on center spacing. Okay, so let's talk about water applications. All right, I keep telling you that water is the #1 enemy, but we get to do water applications every year, hundreds and thousands of square feet every year, because we know flat buildable land is premium, and a lot of people like to live next to water, right? So here's a meandering stream through a golf course. Now, the biggest thing with water applications, as long as you know two things, and really it's just the water elevations. What is the high water mark? What is the low water mark? You have a general idea of how you're going to build this water application. So again, what is your high water mark? What is your low water mark? Now you'll notice sitting on the screen, you're talking, I see this fabric, right? And if you remember our conversation, you're like, well, Chad, you don't like fabric vertically. But remember I said in water applications, I do like fabric, because what I'm trying to do is put fabric in the base, because that's going to help bridge over some soft material. And then this fabric is going to go behind the grid. It's not going behind just the block. It is the entire grid zone. Because remember, normally with water applications, we've got some softer soils as we go through this. And so what we do is we lay this fabric down the entire base area and extend it to at least 1 foot higher than your high water mark. That is where your water elevations come into play. As soon as I know my high water mark, I know how far I'm extending this fabric, at least 1 foot higher. Now, low water mark for this application was controlled by a concrete weir, so this was a stream, and so they knew the elevation pretty easy. So I'm going to raise my pipe up to the low water mark. Okay, that's where the low water mark comes in. High water mark is where your rock and your grit or your fabric goes. Low water mark is where your pipe goes, because everything behind this wall is all clean stone. It's not just 12 inches anymore. It's all, the entire infill area is all clean stone. And then notice we bring in a little bit of a riprap, especially if we got moving water, a little bit of wave action, maybe some flowing stream, that kind of stuff. We got to make sure we protect that fabric, protect that toe, so that wall doesn't get undermined. Right? So we do water applications all the time because we're not trying to prevent the water from coming in. In fact, we know the water is going to come in behind this wall, but the water in front and the water behind, that balances. I don't worry about that at all. It's the water that could get trapped above this low water mark. So that's why we always extend our fabric, we extend our rock up to at least the high water mark or a foot higher than a high water mark to prevent these rapid drawdown conditions. Okay, so in that sense, when you think about water applications, you're creating a wall that's going to sit in the water. That's the whole point. Okay, and then we're just making sure the water does not get trapped behind this wall. So things to consider. Water applications more often are usually small little shoreline applications, or like detention and retention ponds on commercial applications. The detention ponds are just to handle that storm water, and that storm water, it's only there when it rains. So your low water mark is at the bottom here anyway. So your pipe would move to the bottom of your wall. Waterfront applications, you got to find out where that elevation is. So please keep in mind, the two things you need to remember are what are your high water mark and low water mark. As soon as you know that, you got a really good idea of how this is going to be installed. Okay. All right. So why do these walls fail? Well, obviously, if they try to dump the truck the wrong direction, bad things tend to happen. So this was got a little close to the edge and went over the top. So we were fortunate this was an inside arc. Wall didn't fail. The driver maybe had to get a new pair of pants, but everybody was fine in this. But we know the number one reasons why walls fail is because of surface water. Please do everything you can to divert the water out and around and not towards the wall. And so what water will do, it'll just magnify any mistakes that were made. So you look at this picture and you're probably looking at quick, Chad, where's the wall rock? Where's that clean stone? Where's the grid? I mean, this is maybe a 4 foot high wall. Maybe they need to use grid in this. So water will just double the pressure that it feels by itself, and it'll get things to move for you. So, but if the expectation is the water is going to follow this slope, go over the top of the block, you're going to be in for a rude awakening, because all it takes is just a little bit of settlement down here, and now it's going to hit the back of the block and start to saturate your soils. And water will flow over the land faster than it'll flow through any kind of stone. So we always try to make sure we've got that water going out and around. Now, another reason why these walls fail: improper compaction. So first two reasons, right? Water management and compaction. This is where we see when bad things happen in the soils. If you've got a lot of compaction or settlement, excuse me, if you got a lot of settlement, it's going to drag that grid down with that settlement. Now, blocks don't settle. Compressive strength of the blocks are 5,000 PSI, and they're not going to settle. So what happens is it starts to overstress or tear the grid right here, and that's a big problem. okay? And so we try to minimize that settlement by compacting the soils, and that's where these compacting lifts. Make sure you get the inspection done if it's being required. Make sure you know this in advance, so you're not surprised that now you're saying you got to call for a on-site inspector and he's going to be there and slow you down. Be conscious of that when you're putting a bid together, especially on commercial work. Now, improper use of equipment. You get that equipment too close, bad things tend to happen. And not that I like this picture, but it definitely hammers the point home. What happens is obviously this guy was trying to do some final grading, and every time he turned, he bulged that wall, right? And so he got too close to the wall and the wall moved out. Now, what's interesting is the wall builder wasn't even on site for this, right? So he was pulled off. He got pulled off to another job. He was basically almost done. He just had to come back and maybe cap a few things, do some final cleanup. But so he was off the site, and then the final grading contractor is the one that got a little too close. Fortunately, they had pictures, right? So now they had pictures of the way they left it, right? And it showed it a nice straight wall. And so again, getting back to my point, take a lot of pictures. That way you've got documentation all the way through and how you built that, especially if you're going to be pulled off of a job site for a while, residential or commercial, doesn't matter. Take a picture of how you left the site. That way there aren't any surprises that can't be documented when you come back. Now, subsurface infiltration. Now, if you build on a natural spring or if you got water flowing down below and you don't handle it, bad things tend to happen. This was a project in New York where the wall builder, again, tried to do it the right way, but didn't stand his ground. He's excavating for his trench, sees the water flowing, and gets the general contractor involved, says, hey, listen, I got to stop. I got to get my designing engineer out here. We got to handle this water. Well, the general contractor put so much pressure on them because they were already behind schedule. He was worried about liquidated damages on a project of this size. And so he says, no, build this wall. They documented the conversation, all that great stuff, as you can imagine, but bad things happen, right? I mean, all of a sudden you got water moving, you got the soil moving, and so you've got issues that now have to come back and get fixed. And again, nobody gets paid to build it a second time for the full price. And so everybody's got a little bit of a skin in the game with this. And so bringing in a little French drain system as part of his base would have fixed this problem, no issues whatsoever. And then improper grid placement, you can only do the drop and kick when you have biaxial grid, or there is no such thing as fluorescent orange layers of geogrid. We've used this picture forever, but if you look real close, you should see fluorescent orange. That is construction fencing. That is not the right type of grid. We got to ensure we're using the right type of grid all the way through. So one last case study of what not to do. This is a project that was basically like a perfect storm, right? They got a 12-foot high wall. You can notice the grid spacing. He's got 4-core spacing. Now remember, we always recommend a 2-core spacing already, 3-core spacing max. So he's already pushing the limit. Notice his grid length. The grid length is only 6 feet, so he's not even at the 60% that we'd be designing for. He just took the grid roll of a uniaxial grid and he rolled it out parallel with the wall that was only 6 feet long. Now, it gets worse, guys. These are his downspouts. He figured he had a tow drain down here. He could tie in 2 of his downspouts to this tow drain, okay? Now, that was his design. His construction activities weren't even better. So he had over 8 inches of settlement. So much settlement that it started to shear the pipes off because it got so much movement. It sheared these pipes off or collapsed these pipes. So now he's got water ponding on top, okay? And then he's got water coming in from his downspouts. So we know this is going to be a problem. So much water built up, that hydrostatic pressure built up, that it actually overstressed the grid, because the grid was rolled out the wrong way, and we had these 10-inch strips of grid. So from the back of the lip to the overstress, about 10 inches wide. And we're like, what is this? And we're trying to figure out where this grid was coming from. And when we realized that it was the grid that was trapped in the block until it overstressed. So major problem. Let me get to some pictures. Okay. So here, when you look at this, let me get to this one here. When you look at this, you can see 8 inches of settlement. So major movement in this wall. And if you look at from a face view, you can see how the failure centered on the pipes itself. Notice how the grid goes continuously through this wall. So it's sure sign that it rolled the grid out the wrong direction. Here is a couple of these strips of grid laying around here a little bit. But obviously nobody's happy. Nobody wins when a wall fails. Absolutely nobody. You can see how these pipes have been collapsed and stuff like that, because now people are trying to lawyer up, trying to figure out who's going to pay for it. And so we really want to do everything we can to avoid these problems. Now, this didn't go anywhere. You know, we showed him that this is how he engineered the wall. We didn't even talk about his improper compaction or even the water and stuff like that. Here's how anybody back in 2000, or actually 1998, I believe, this is a pretty old project, you know, how anybody even back then would have engineered it. And the reason why is if you look close, and I don't know how big of a monitor you guys are looking at, but his safety factors for grid, his bottom 2 layers of grid, he had a safety factor for overstress of less than 1. Well, if you ever have a safety factor less than 1, it's only a matter of time before it fails. That means you have more force on it than it can hold back. And so they changed their tune. They hired the right design professional. They hired the right contractor, and better things happen. And this is not his project. This is kind of a recap of where we're at here, guys. So that's why I keep coming back. These retaining walls can provide the solutions people are looking for. So you can see a pretty good structure, some parking lots and stuff on top. But how do we make sure we are controlling your project? Well, obviously, think about what we talked about today. Okay, what are the heights of your walls? What are the soils? Obviously, what is your surcharges, slopes? What are your water runoff patterns? Kind of getting back to that planning bullet point that we come into there a little bit. What are things that are going to influence your retaining wall? How much room do you have to work with? Remember that total wall area that you have. It's not just the thickness of the block, it's with that reinforcement. Do you have enough room for grid? Maybe do I need to propose a no fines concrete option? You know, that kind of stuff. And then the base material, I keep coming back to that as well, right? You cannot build on soft material. If you got to make sure that's nice and stable. Now, when you're talking about terraced walls, okay, multiple terraces, try to break these up, make it a little bit more flowing. Maybe it's trying to match that natural slope that is on that hillside, but you just kind of create these little plateaus. When you're doing terraces, if I've got multiple terraces, we typically recommend global stability. Global stability is that entire hillside, right? It's not just the individual walls, it's the entire hillside. So if I got 2 or more terraces, we generally recommend global stability. But then the height of each tier, the distance between each tier, and you know, if they're going to be independent, I want to see who is paying attention. So somebody in the question feature put in, what is the distance they need to be apart if they're going to be independent? Okay, I gave you that kind of thought when we were doing the terraces. If they're going to be independent, what is the distance required? How far apart do they need to be? Great. 2H. I don't know if you qualify, Jill, but I'll give you that. 2H, twice the wall height. There we go. Now they're popping in. I love it. 2H. And that is a great rule to remember for anything, right? If whatever is in that 2H distance, if it's a terrace wall or a standard wall, that is your zone of influence that you need to keep in mind. So now when we're talking about water applications, we just covered this. We need to know what is your water lines. Average water line, maybe, but the critical ones are your high and low. Your low water mark sets your drain pipe. Your high water mark sets your rock and fabric, right? Now, if you got standing or moving water, this is where you get in that riprap. Freezing water, really, ironically, the only reason why that is a problem is if that freezing water is near the top of the wall, because water generally freezes up and it might dislodge the top couple courses. But if that freezing water is down below or towards the base of that wall, it's not going to lift the wall up. So freezing water is usually right there, and then that excess wave action. So when you have along major roadways or waterways and stuff like this, this is where you would probably not recommend a segment or retaining wall. Any kind of ocean fronts, even along the Great Lakes for you guys, I would generally not recommend Allan block being right along the roadway as you go through this. Okay. All right. Now, how do we ensure these walls last a lifetime? Well, what do you think my first couple recommendations are? Right? Water and compaction. Do those 2 things, and we're going to be in pretty good shape. And then keep heavy equipment away from the wall. follow the recommendations for installation, and then provide good temporary drainage at the end of each day. That's the key. Water is going to try to find the lowest point in a construction site, and so we want to make sure we avoid that. So what have I missed? So those of you guys that maybe were working ahead, you're probably looking at pre-construction meetings and tolerances and stuff like that. I want to challenge you all that every project you work on should have a pre-construction meeting. Every single one. That could be just you and the homeowner meeting together. It could be you sitting in the job site trailer with the engineer, the general contractor, but you need to use that pre-construction meeting as a guide or as a way to start that communication. Okay, what are the expectations of that retaining wall? Who's signing off on that retaining wall? After you're done construction, who finally gives you the blessing that, yeah, you get payment? Obviously, on a homeowner or residential job, it's the homeowner, that's easy. But on a construction site, is it the architect? Is it the engineer? Is it the general contractor's representative? Who is that person? Right? Sometimes it's whoever hires you, but it's important to know what the chain of command is here a little bit, guys. So pre-construction meetings, and we've got a checklist. If you go to page 67, 68 in our construction manual, you're going to see that it's a nice little pre-construction checklist. It talks about a lot of the things that we covered today, who's verifying soils, you know, that kind of stuff right there. Now, tolerances. We know these walls are going to move. How much can they flex or move before there's an issue? And there's really a couple of them that I really want to point out and bring to your attention. So these again are in the construction manual, but also in our spec book. And there's a little bit more information in the spec book, which you guys also have if you look at your contractor certification binder. The big one is rotation. Okay, remember these are flexible, so they are going to flex. But if I start at 6 degrees, we go plus or minus 2 degrees before there potentially could be a structural issue. So that means you can roll over to almost 4 degrees. And if it's within those construction tolerances, that's what we as an industry kind of judge everything to. You know, if you're within that tolerances, structurally you're fine. Now, if you roll past 4 degrees, now we might say, okay, let's look to see how this changes the engineering, what's causing this additional rotation. You know, so now you're ramping up that level of interest. Same thing with that vertical and horizontal control. We know these walls are going to move. How much can they move? Well, in a 10-foot run, you can move 1.25 inches, whether that's dropping, whether that's bulging. And let's face it, in a 10-foot run, you drop 1.25 inches, you're going to see that. And it's a bad joke, but if you think about it, if I drop 1.25 inches, that looks like I got a smiling wall. And a smiling wall is not going to mean a happy customer, because that is a problem. But what that can come in is if you ever find yourself building on top of utility trenches or something of that nature, nobody ever compacts utility trenches. They get the utilities in, they throw the dirt back on, and they move on. That's why you see these holes, potholes, or stuff in and around the roadways. They settle so much. Around your houses, they settle so much. So if you ever build on top of a utility trench, bad things happen. So you might need to bring in some grid to overstress or overlap this a little bit. But this is where that 1.25 inches comes into play. And the same thing with differential settlement. It's just a certain percentage over an area of question. So it's 1% over that area in question as we go through this. Okay, so I'm going to finish up here, and then we'll take, well, let's see, it's 11:43. We're almost 4 hours into this. I'm going to finish up here, and then we'll take a little bit of a break, have you guys start looking at part 2, and then we'll come back. Well, yeah, I think we'll do it that way. Otherwise, I could just push through this here a little bit. You know, I got a couple more slides to take you through, actually, just trying to weigh this out, because this is usually about 5 hours. So I want to make sure you guys have a little break to maybe grab a quick snack or a bite to eat, but we should be done in about another 45 minutes at the most. So if I can keep moving forward and you guys take a late lunch, maybe that'll work, and that'll just kind of streamline things. But you guys let me know. Normally, if I do this live in person, I just usually take a poll of the class, but it's kind of hard to do that virtually. But why don't I just keep rolling through this here a little bit, guys? I don't mind, and we'll just kind of finish this up, and we'll finish up here in about half hour, 45 minutes, and then we can kind of wrap things up. But as far as the case study goes here, guys, This was one of the larger projects we have in North America. It's down in San Diego, and so they had a campus. You can see how close these buildings are to the base of this wall. They had a campus that they wanted to expand, so 100,000 square foot of Allan block was used. So we love it. That'll get you to the master wall builder level pretty quick. But you know, over 50 feet in grade change. And now on the cut application, we couldn't just use grid the whole way, even though that would have saved us a little money. But there's some federally protected land and the property lines. So the top portion of that wall we were able to construct with grid, but the bottom portion we went with soil nails. And soil nails is exactly maybe what you're envisioning. It's like that hammer and nail, right? You drive that nail into the wood and it prevents it from being pulled out or moved. And so we're going to drive that nail into the soil, and so it prevents that from being able to move, and it's a tie-off point. So now we can do some shotcrete and some liquid concrete right here, and really the Allan block is kind of that veneer facing of that, and that's what's being shown. So the top portion of this wall has been built with the grid that continue their activities, but as they cut and excavated to move this dirt over to the fill side, they just mark where those soil nails are going to be placed. They drive them in, and then you can see that shotcrete face. Not all that aesthetically pleasing, so that's where the Allan block came in to kind of match the aesthetics of the rest of the site. So great application. Obviously, we've got slopes, we got seismic, we got different types of grid that needs to be done. We also had the requirement of making it a living wall. San Diego County wanted vines to be able to grow on this thing. So every sixth course, if you look close, every sixth course, we exposed the core and created little planter pockets. So that way they could put a little drip edge in there and put some vines and grow. So that way they had 80% coverage of this wall. So great project. Was built right before I started, so I had no involvement with this. So it's over 20 years old already, and I was out there about 8 years ago, took some pictures of it. Looks great. And it's already gone through some minor earthquakes and stuff like that. So no problems whatsoever. Again, getting back to using a thorough plan, design, build approach to ensure you've got success. And this is a contractor over in Spain, and you know he says he's the #1 wall builder. And I don't know if that's self-proclaimed, but I do like the way he says that there's opportunities in this industry. And you guys have recognized this. You guys have been building walls for a while, and if you use a plan, design, build approach, you can be pretty successful. And build a company and expand a company and provide some longevity and some food on the table for your employees and families. So great industry to be in, and it's always growing. And that's what the beautiful thing about this. All the flat buildable land is gone. So any kind of expansion is requiring a retaining wall. So we see good things on the horizon for our industry. You know, we see people reinvesting in their property. We see people expanding in new developments. Sure, there's been some industries that have been hurt by 2020, but we also see some industries that have flourished too. So use the contractor certification program to find and help get those leads. You know, and you've got a partner with Redding Rock and Allan block every step of the way. We've got an engineering team here that can help you on the technical assistance. Your first line of defense is that Redding Rocks team, that sales support that you have. But if they don't have questions, I know they're quick to shoot an email, a text, or even a phone call up to us. But we're happy to help local engineers make the right decisions. So we're not licensed in Ohio or Indiana or Kentucky or Illinois, or you know, we're not licensed in every place that you guys are handling. I mean, we can't be licensed in every state, country, and continent that Allan block is because we're worldwide. So we've always relied on local engineers. So with that, we've got design tools that help them do that. That's whether that's on our website, so typical details, things to consider that way. We've got an estimating tool that you guys should be aware of. Now, you might get some assistance. I know the Redding Rock team will help you do some material estimates. Maybe you got your local distribution partner helping you with some estimates. But at the end of the day, as the contractor, you guys are responsible for the numbers that you provide to your customers. So I would use every tool and resource available to maybe double check or validate these numbers. And there's an estimating tool on our website that you can download. It's free. And for landscape applications, you can just bring in how many courses and what the length is, hit calculate, or for commercial applications, for courtyard, you can decide how big of a courtyard you're bringing in, how tall, then how many pillars. All right, I just want to double check. Yep, everybody, I just got a little bit of a glitch on my side. So looks like we are, yeah, looked like my internet had to repower. Okay, so I'm gonna just double check this a little bit, but everything is 3D modeled, right? So you can bring it into SketchUp, you can add your details and stuff like this to it, because SketchUp, you can bring in the flowers and the patio packages and the people and stuff like that. So it's all meant there to be a resource, and it's part of just the tool, because it helps you sell your program. We've got an advanced contractor certification class meant to focus on these tools that help you in the residential world. And I know Reading Rock is participating in that, so be aware, look for that opportunity. Now that you're certified, you can come into some of these advanced classes as well. But it all centers on providing tools and resources for you guys to be a little bit better at what you've done. Product, you know, the courtyard collection. This is that above grade seat wall. I just bring in a little bit of information. It's meant to reduce cuts. That was the whole point with the courtyard collection. Let's face it, we know when you cut block, you got to follow the new silica dust rules, and 1926.1153, that is the regulation that they're enforcing now. And anytime you see that dust, that could create a little bit of a problem. And so when you're talking about this, that's where you got to follow the recommendations of using, you know, water or vacuum collection systems, because these violations can add up pretty quickly. And I'm not trying to scare you here, but let's face it, if we're in a room and I got 5 of you, not in a room, if we're outside on a job site and there's 5 of us building the wall, and I go ahead and take it upon myself to make a quick cut in a cap, and or maybe cutting caps, and all 5 of us are working in this area, the violation is just not for me, the violation is for all 5 of us. And they can write 5 individual violations, and that just adds to that problem. So be aware of what the OSHA requirements are. Basically, if you limit the exposure and take measures to protect your workers, you're probably in pretty good shape. Right, and so that if you're doing your best practices to use a water saw or a vacuum collection system, chances are you're going to be in pretty good shape. But we just know cutting costs you money, and so if you minimize your cuts, you're in good shape. That's where these above grade seat walls, that's where Allan block, even the Allan block retaining walls, we try to minimize your cuts. So here, the courtyard, you can see we're putting this right on top of the Europa here, or even just stand alone. But these are just like that giant concrete Lego trying to define that outdoor living space. Here, you know, whether it's that patio between the pool decks, literally the customer said this is the adult play area, this is the kids play area, but it's just, we had numerous opportunities this year, right? Let's face it, the hospitality industry got hit hard, and so they were looking for ways to expand their outdoor eating area. So we had some courtyard being built around outdoor areas that weren't quite there before, but they just extended their outdoor dining areas to stay open, right? And so great ways to kind of define that area all the way around. Okay, let's see, let's get into, got a lot of pictures here, but what I like about the courtyard collection is it's meant to be thought-provoking. It's just meant to try to give you ideas. So we've got different patio packages already pre-formed. So there's 12 different patio packages to try to help you sell concepts to your potential customer, whether they want that grill surround, fire pit, again, extension of their outdoor seating, but use those as a way to kind of educate that potential customer. Because I'm sure some of you guys can relate to this. You have customers that really have no idea how much these things cost, right? They've got $500 in their pocket and they expect the Taj Mahal, right? They want this massive outdoor patio, whatever it is. On the flip side, you got some guys that have no idea because they've got this enormous budget, and you keep saying, well, for that I can do this, 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 and you can really extend that vision that they might have. They are hiring you as that trusted advisor, and this is where that certification really comes into play. You are bringing in instant credibility because you have your experience, you've got your past work, you've got your certification, and you're establishing yourself as that trusted, authorized, trusted advisor. So now you can make some recommendations. Hey, have you thought about adding that landscape lighting? Have you thought about adding 2 pillars at the end of this to kind of frame in an entryway? So you're not trying to, you know, soak them for every dollar they have, but you're also trying to give them things to consider to make their project better, especially on that retail or residential side. Okay, but the Courtyard collection is just 3 block shapes for the post and panel, and then 2 caps. Redding Rock has the rock cast caps. In fact, if you look here close, you can see some of the rock cast caps being used for the pillars, but others, here's the wall caps being used. But I call this as a trifecta, right? This is where you get the patio, you get the retaining walls, you get these above grade seat walls. You're really kind of maximizing your vision or maximizing their vision for their backyard by just offering things that you do on a daily basis, right? And that's the whole goal. So that's the end of the presentation itself. And so when you do this, and I'm going to keep going, guys, because I've got about 15 minutes and we're done. Instead of taking a break, I want to just kind of go through this, and then you can work on your test on your own. Now, please, with this test, I've already had a couple emails back, but please send it to C. Julius. In fact, what I'm going to do is I'm going to put it in a chat right now, but it's C. Julius at allanblock.com. And that way you can send me your completed test, both parts 1 and 2. Make sure your name is on both. Make sure each one of you guys that are doing it does go ahead and send me a test. So I just sent you a chat. So it's cjulius@allanblock.com. But make sure you send me those tests, and I will just keep track of them. I'll let you know how you guys do. If you absolutely bomb it, then it's a reflection of the teacher, not the student. That's how I look at it. But there's reasons why you guys are getting certified. At least I hope so, right? There's value in this program, right? How do you become certified? You pass that test, right? So you send me your test, and then you build a wall. Now there's an intermediate step in there because this is virtual. You're going to work with Redding Rock and make sure you do a little hands-on training. That hands-on can be on your next Allan Block project. They can just make sure you got some corners, or maybe they have some corners with them. And so I know the guys from Redding Rock are sitting there going, what? Now we got to have corners in our trunk and we're going to be doing this? But work with them and complete the hands-on portion of this, whether it's at their RDCs, whether it's at their shop, whether it's at their next job site. Go over some of the tips and tricks to build these walls, but then you complete that certification process, and then work with this. Leverage that certification class. If you're interested in Home Advisor, basically it just gives you a little bit of reduced initial cost. Also gives you some quarterly rebates, stuff like that. But there are things in the hands-on that we want to cover. All right, and so I'm going to do these videos here real quick. And so it's going to be some product identification. I'm not going to go through all of them, but I do want to let this first one run. And then we're going to go through some basic installation steps. So the AB collection, this is our workhorse, right? And you've seen some of these pictures. You've seen me talk about this. It is that split face block, 8x18, 12 inches deep. It's the modular shapes that go along with this. So like I said, if you've used Allan Block before, it's probably from that AB collection. It is the only collection that has the different setbacks, right? This is why I want to play this video. So whether you're doing 12 degrees with the AB stones, 6 degree with the AB classics, or near vertical with that AB vertical. Some of you guys do GRS, IBS applications. That's where that near vertical wall will come into play. And so that AB collection is used, and what I mean by the difference in setback, it is the lip and notch configuration. So these are just, I took some of the block that we have in our hands-on area. This is your AB stones, this is your classic, this is your vertical. And the reason why I know that is I look at the lip and notch configuration. If I got a very shallow notch, right? Very shallow notch that pushes the wall back. And so that's my 12-degree system because it's pushing it back into your hillside. If I've got about a 3/4 inch notch, but my lip is still 2 inches, that's my 6-degree. That's the standard block that we have out there. If I have that same type notch, 3/4 of an inch, but now look at the lip, it's only about 1.5 inches. That's my near vertical. So that's that AB vertical when you're all said and done. So you guys know, you guys can tell the difference, especially some I know the Reading Rock staff works at the RDCs and they're working the yard. You can identify the block even if a pallet label falls off. You can look at the lip and notch configuration and identify what block that looks like, right? And so it's just a 2-inch lip, 3/4 inch knob, that's your classic. And normally on a pallet, they're face to face and you can kind of see that. All right, the Europa collection, I'm gonna skip. Aztec collection, maybe I'll let this play, but this, you can see just the different aesthetics. I really like where this is going. People are liking the little undulations. Some people actually like the edges marked up. We've had homeowners ask the contractor to come back with a paver and hit the high points, so it's a little bit more pronounced. You can kind of see that here. Other people like it a little bit more smooth. So it really depends on really the aesthetics that people are looking for, but it's a great system to work with. Now, Fieldstone, I'm gonna let this one play here. This one is that 2-piece system. All right, so breaks away from your traditional Allan block a little bit, but you can see the aesthetics are more of that chiseled look or more of a stacked stone look, depending on what the collection they're using. All right, this is a Cascade, more of a framed in look there. But here we're just gonna go ahead and stack that up. Now, for the install, it's pretty simple. You start with your facing and then you go into right away your back pieces, okay? So here you can see how that anchor unit just slides into the facing element. And what's nice is you can use a little bit more recycled material in that back piece because we don't always care what it looks like. So it's just as long as the compressive strength is there, we're in pretty good shape. So you just slide that in, you use 2 of the anchor pieces in your 824s and you're off to the races. And so that's how the Fieldstone differs from your standard Allan block. It's got that front lip, bottom notch for your standard ones. Here we've got a rear lip based on your anchoring piece when it's all said and done. Okay. Now courtyard we just covered, and I'm gonna skip this. I do want to show the fence. The fence to me is something that you guys can leverage. Again, these are just blocks stacked on top of each other. Yes, we're gonna fill some of the posts with concrete and steel. Yes, we're gonna go ahead and make sure the panels have some concrete and steel in it, but if they're not 100% filled, you're creating what we call bond beams. And so please, anytime you're working with a customer, whether you're doing some patio work or some pavers or retaining walls, and you start hearing them or seeing the fact that they need some type of a sound barrier or privacy or some containment, that kind of stuff, keep in mind you've got a system here. The way I kind of explain the fence system is that if they want the benefits of a concrete system without all the costs associated with it, I would have them look at the fence, right? So this is something that you can do, and it's actually relatively economical, right? I'm not going to be able to compete with chain link or wood or anything like that, but if they want a concrete system, this is going to be one of the most economical solutions that they have for them, right? So just a great way to bring value, and again, maybe something that you can do. And if you want to get into the fencing system, we've got a certification class that goes a little faster than this, but we've got a training class to take you through the fence as well. Okay, so let's talk about how these walls get built. All right, there's a couple tips and tricks that I just want to highlight. Again, I'm not going to go through the full video here, but I just grabbed some of these older videos to kind of show you some highlights to emphasize what we already talked about. So when you do step ups, remember we want to try to have at least 1 block buried before we do our step up. And so try to find your lowest point and excavate to that lowest point and do your step up, because it's going to be much faster. So again, we always go 6 inches of rock, and then for every inch or every foot in a wall height, we bury that much in an inch. Okay, and that's the goal. That's how much block we want to bury as we go through this. Okay, so now as they do your trench, okay, we're showing about bearing a little bit more block when we've got a slope below the wall. So here, I'm going to cut into the hillside, make sure everything gets compacted, okay? Here we must be using a corrugated perforated pipe. So we bring in our rock, we bring in our first course of block, and we level this up. And because you got that height of block, you know what you need to excavate for your next area. Now, normally you've got this all excavated at the same time, but you can see how you've got that area being able to compact and step up in an 8-inch increment. But notice, this is what I want to show. You've got a full block buried before you transition up that hillside a little bit, okay? And then you just kind of repeat those steps as you move up. Now, some of you guys have done this where you're trying to go up a hill and you're trying to maintain a line. Remember, every time I go up, I'm going to step back a little bit because of that setback. So either you need to angle your base, so you actually angle your bases if you're going into your hillside a little bit, so it accommodates your step up, or you need to kind of modify the block or tweak that block so you come back to that area. And we've got a tech sheet, it's in your binder on how to do that. So how do you maintain a straight line going up a slope? I want to show you these curved walls. This is part of that hands-on that we normally do as far as our stationing. We love curved walls, but there's a couple tips and tricks. So I'm going to show you curved walls, general radiuses. I want to show you how you can do some tighter radiuses. And then I also want to emphasize how you do the grid. So I'm going to let this video and I'm going to kind of narrate this as we go through. So I'm going to talk about tighter radiuses as well, and I'm going to talk about how you do the grid. Because if you do really tight radiuses, this is where you might have to modify the block. If you keep your radiuses general, you'll never have to worry about modifying the block. If you have really tight radiuses on a small little landscape job, use that radius chart, maybe even recommend them doing like a Jumbo Junior or a Palermo or something like that. Here I'm showing you how you just go ahead and knock the wings off. Just use a hammer. Doesn't have to be anything pretty, but we knock the wings off, and that's how we tighten up the backside of those blocks to create those outside radiuses. Okay. Now, like I said, the tightest radius you're going to make is about 4 feet. You can go obviously tighter with that half high unit. Right. So when you do these curves, we're just going to start with that straight wall, and then we're going to mark that radius. Now, if you got to go tighter, like I said, beautiful thing, use that half high unit, you can go to about a 2.5 foot radius. And you can sprinkle a little bit of this in your retaining wall, and a lot of people wouldn't know. Now, if you're doing some tight radiuses, this is where that modification, remember, we never want to modify the lip, but you might get a little bit of a gap that shows up. And so we're just going to deepen the notch that allows you to slide that block forward a little bit. Now, I hope if you're smart on how you do your layout, you can minimize any of this. This might only be your top course or top 1 or 2 courses. If you're starting to make these modifications down towards the bottom, you're going to probably have some problems. Now, when you do these radiuses, this is where that offset really will come into play, because your setback will change the length. And so just try to maintain that 1/4 of a block overlap, and you're in really good shape. Okay, curves, you saw this once already, but when you do these outside curves, the grid is going to overlap a little bit for you. So we just go ahead, get these grids in there, make sure you got 100% coverage right at the face, and where it overlaps, again, no gaps, no overlaps, just lift, let me try that again. Lift a layer, piece of that grid up, get 1 or 2 inches of rock between there, and put it right back down. That's all you got to do. We like that grid, rock, grid interaction, and we're in good shape. So you can imagine, we just talked about these inside or outside radiuses. Inside radiuses, we still try to keep a 4 foot minimum radius, just because we try to not try to make it look so, I guess, I don't know, chunky is the right word. You got 18 inches, but if you ever do need to, you're going to get a little gap that shows. Just modify the inside part of the lip or the notch, and it allows you to slide that forward. So again, you always modify the notch on the bottom side. Never modify the lip. The lip is that shear key that we keep talking about. Okay, so you just go ahead and drop your blade, or just, you could even take a hammer and chisel because you're not seeing it, and you can kind of hide that. Again, I hope this is only towards, you know, the bottom part of the wall in this case, and not the top. So now when you do these inside curves for grid, very, very simple. always just go ahead and get these rectangular pieces in there. You're going to get these little V shapes or pie shapes because we want to keep 100% coverage at the face. But then as it opens up, just make a little mark, you know, that chalk line and stuff like that. And then in your next course, you know where those marks are, we just put a layered geogrid over the top. Now you wouldn't even need to go have these go in the block if you wanted to, but I do know a lot of guys just put them right in the block and go all the way through, okay? Pattern walls, I'm gonna kind of skip, but finishing options, I just wanna kind of recap here a little bit. But finishing options, we're just gonna kind of just use the caps. We're gonna use some corners here. You can do the 4-inch step up, especially when you're doing these ashlar patterns. But we know that you're gonna just keep that lip and notch there. So use that as an edger if you need to, right? I'm showing you here a little bit of a blend. You can bring that mulch right up to it. You can bring that topsoil right up to it. Really extend the look of that planter. And people can be, you guys have been very creative with this, which has been kind of nice to see. But obviously when you're doing caps, we're just gonna be cutting those as we go through this. Now we're showing one of the quick and easy ways to do it. I'm gonna give you a little bit of a tip. I like making cuts on both sides of the cap, not just, so I'm actually cutting both edges of each cap, because if you look real close, the face lines up, but the back shows to be a little bit longer. Now I would just make that minor adjustment and take that distance out of both sides or both edges of those cap, and then you fix it, okay? All right, the last thing I'm gonna just kind of show is courtyard, because this one to me is more hands-on, okay? Courtyard, if you build a post, you know, this is just stacking. Let me go back here a little bit. When you do courtyard walls, this didn't go as quickly as I wanted it to. When you do the courtyard walls, let me see if I get this to play. Sorry about that. You're just gonna stack the blocks up. You've got the raised nubs, and like I said, it's just kind of that giant Lego as we go through this. And so here I'm just kind of showing this application, but what you see is there's going to be Yorks and Dublins, and you're going to use those in combination to go ahead and build that wall. Now with courtyard, you can do it right on top of existing pavers, patios, or you can base them out similar to your patio, right? So what a lot of the guys tend to do is they extend their paver base a little bit further, so then they're not taking up their patio. But I know a lot of guys that are going right on top of these existing patios, and as long as they're obviously reasonably flat and level, you can do this. But you can see how they just use a combination of Yorks and Dublins, kind of just locks it together with that raised nub. Now, if you wanted to finish this wall with something different, maybe that rock cast unit, you can just flip these blocks upside down, okay? And so you'd have this last course upside down, and now you got a flat edge on top. And so you, instead of using the wall caps that we're showing, you can use that rock cast cap. Here we're just showing we can use that wall cap and flip it back and forth. We do recommend, same thing with the retaining walls, gluing these in place. And so a nice thick bead of adhesive on the block and even on the sides of the caps to kind of glue these in place. Now when you're doing posts are the same thing. Man, I'm having a little problems with my my system all of a sudden. All of a sudden it locks up on me. Let's see if I get this to work. All right, so for posts, it is all just the corner block. The corner block are used, and guys, I would not hesitate offering to do a couple pillars at the end of a driveway, or a couple pillars to frame in the entryway of that patio. For very little effort, you can add some additional revenue to your customer, right? So here with the corner block, we're just using the long side out. That's the big trick. And then we just kind of use that all the same directions, and we square this up, make sure it's level. Again, it can go on top of the pavers, or you can base it out. So we level this up, square this up, and then the next course, you just flip and go the opposite direction. So there is no right side up or upside down with these corner blocks. There are no nubs to them. So you might put a little bit of adhesive on here, especially as a contractor. You get held to a little bit higher standard, but again, they're flat on top. So when you finish these, you can use that the different caps that we have, the 2-piece cap, or that rock cast cap as well. But then, you know, just glue it in place and you're ready to go. Now, curves with courtyard, I've got to play this one because this is probably the biggest headache I see out there. And once you understand how to do this curve, you're going to get this and it's going to fly for you. But the curve, you're going to use the York. The York has got the longer edge on one side. And so we're going to transition this curve going in both directions. You're going to try to lay out 2 courses at a time. If you're trying to transition the curve and the angle is not the same, move it over, right? And that's what she just showed right here. You're going to move it over and then come back and do a split face or split edge on the other side. So now we're transitioning into this curve as we come out. And then we're just going to use the Yorks long side out. We are going to split a Dublin in half. So, or you guys are just going to cut it. But there's already pre-scored marks right there where you can drop that blade. And what you're going to do with that Dublin is on your even courses, you're going to notice this. You're going to try to do Yorks all the way around, and you're going to get a spot where it just doesn't line up. And if you remember, okay, it doesn't line up, take that center split Dublin, that split block, put that 90-degree edge coming into that corner, and it's going to fit. Use the other half as you transition out of that corner. And again, it's going to be obvious. You're going to come in and try to drop a York and it's not going to fit. So you just say, oh yeah, I just got to have that split face or that split there again. So you split one block or cut one block, you can use it transitioning in and out of that curve and you're set. You're ready to go. All right, so that's what I really had for you guys. I want to thank you for your time. I'm going to open up the mic here a little bit. I know some of the Reading Rock team had a meeting that they had to attend, but otherwise, the guys there, feel free to open up your mics too. But at this point, what I would encourage you guys as attendees to do, finish that test. Okay, let me do this too so you can see me. Finish that test, okay? If you have any questions on that test, feel free to shoot me an email. Feel free to reach out to the guys at Reading Rock. It's not new to them. They're very good at what they do. They can assist. I don't have any problem. Like I said, you're not on your own island trying to build a retaining wall. If you need help, let me know, let us know. We can work through that test, but email me your test, or even email it back to that info@Allan Block that you got the original emails from GoToWebinar and stuff too. So, but give me back that test, work with the team, and complete the training by building that first wall. Once you build that first wall, you become Allan Block certified. We send you your certificate. We send you your rewards as well. And then just as a little reminder for the continuing education credits for ICPI and stuff like that, make sure that back page of part 2 is filled out, that evaluation. Once I see that, I know that that'll trigger the ICPI credits. If you do not need the continuing education credits, you do not need to fill out that back page, okay? But yes, what I want to do now is just thank you for your time. I have not seen any other questions. It looks like technical difficulties are over, so everybody can see and hear me, but I haven't seen any of the questions. Guys at Reading Rock, anybody want to add anything or say anything before we pause? But if not, no big deal. What I want to do is just thank you again. Stay safe out there. Enjoy the holiday season. Merry Christmas to everybody. I know it's going to look a little different here in 2020, but please let us know how we can be a resource. We get to do retaining walls every day. As fun and exciting as that sounds, that's what we get to do. And so please let us know how we can assist you on your next project. So with that, guys, I'm going to sign off. And then I'll just kind of monitor the emails as they come in for these tests. But look forward to working with you guys here soon. Thanks again and Merry Christmas.